Hey folks, welcome. Just getting everything where it needs to be. Today's going to be an interesting one. It's going to be a little different. It's going to be a little different. So let's see. I need to send out a ping on Slack. There we go. And now we're golden. Cool. So today we're going to do a couple of things. To start with, I was recently linked, as in a couple of hours ago, linked an interview with Andrew Kelly, the creator of Zig, and I want to watch this. I want to watch this together. And I respect Andrew Kelly quite a bit, and I'm curious what he has to say. I've reached out to him personally for some advice on creating language communities and nonprofits, everything like that. He's been quite helpful. So I want to see what he has to say in this. So we'll watch this, and then we have some coding to do on the Jank side. I've already optimized the ray tracing benchmark to be faster than Clojure. So we're gonna do some other work that's related to wrapping up all of that optimization stuff. And then we'll have a new blog post coming out on Friday, which is going to cover all the juicy details about what went into optimizing that ray tracer. But for today, to start with, let's jump into this. I've skipped ahead 43 seconds because it was just spoiling a bunch of stuff that's going on in the following hour. So as far as I can tell, here's where it actually starts. So you should be able to hear the audio when I play this. If you can't, then let me know. And we'll watch together, and I'll pause and talk when I want to.
Andrew Kelly, we already have C, C++, Rust, Go. What made you build Zig anyway?
Well, it's funny that you listed those languages specifically, because that is exactly the set of programming languages that I first tried to use to build a digital audio workstation just before I pivoted to working on Zig. And when I tried to work on this project, with each different language, I ran into a different set of problems that I found insurmountable. And at the end of this process, I concluded that no, it's not me that is having a skill issue, it's the programming language that's the problem. And so from there, that's where I developed the hubris of making a new programming language.
Andrew Kelly, creator of Zig programming language, quit his tech job in 2018 to build Zig full-time, runs Zig Foundation on $670,000 a year, banned AI.
What problems exactly?
The first thing that I tried to do was make the digital audio workstation in the browser using JavaScript. And what I quickly realized is that this is too high level. I don't have access to the computer's capabilities that will allow me to make a compelling user experience in this digital audio workstation. So I threw that out the window, and I went to native programming language compilation. The next thing I tried to do is Go. And what I ran into with Go is number one, trying to interact with libraries, like for creating a window or making buttons or something like this, using existing C code does not work very well with Go. And then I also ran into the garbage collector problem. So of course, if you're trying to do audio, you have a real-time deadline. If you can't process the audio in exactly this amount of time, you get a glitch or a skip, and it's completely unacceptable for a live performance software like the digital audio workstation is. So then I got rid of Go. Now I tried to use Rust. And this was before Rust 1.0, but what happened is that I really struggled to write code that would satisfy Rust's rules. And once I did satisfy them, I found that even trying to make little changes would cause a cascade of compile errors that would prevent me from making more progress.
The thing is that, like, I had the same experience early days with Rust. I built maybe one of the first game engines in Rust back in like 0.3 days or something. But this was like 12 years ago. But it was really difficult to be able to encode my C++ ideas in Rust because Rust kept fighting me. And I'd be like, no. I've been using this pattern for years at this point. I know this works. But then Rust would say, no, it's not safe. And oftentimes Rust was right. It wasn't safe. It was a pattern that worked, but that doesn't mean that it was safe. But it wasn't always right. And the language was changing very, very often at that point. Syntactic changes and library changes. So it was a lot of upkeep to try to have any sort of non-trivial project that you're building at that time.
And I remember just feeling very frustrated that I spent a whole month trying to get font rendering work and then felt stuck, like I couldn't even make more progress after that point. So I gave up on Rust and I switched to C++. Then I felt more productive at first. But what happened very quickly is that just a little typo here, little mistake there, would result in a memory corruption bug that would cause me weeks in order to debug. This is just too slow. I can't create a project with this magnitude of difficulty when these little mistakes are costing me weeks and weeks over and over again. After that, I tried C++, but C style. So I actually would compile with the C++ compiler, but I would link with the C linker. And that would give me an error if I tried to use fancy C++ features. So that limited me to only templates and a few other things. But even that, it was the same problem. It's just too easy to shoot yourself in the foot with C++. And for me, that was when I said, I can do better. I can do better than C++. I can do better than Rust. I can do better than Go. I can do better than JavaScript. I can do better than D. That was my hubris.
Now, Zig. What is Zig used for? What problems does it solve?
Zig is used when you want to have full control over the computer. You don't want to leave any performance on the table. You want to have the best possible performance and the best possible memory usage. And ultimately, you want to craft a compelling user experience. That's the most important thing. Just before starting Zig, I took a new philosophy for myself to not compromise on the user experience. So I would never say, oh, because I'm using Go or because I'm using JavaScript or something like this, I have this limitation in the software. I would say, no, that's not acceptable. I will change my tool chain if I have to in order to make the computer deliver the best experience for the user. And for me at the time, that was a different way of thinking about programming. It's not what can I do with my tool chain, it's what can the computer fundamentally do and how can I get it to do this using any possible tool chain, maybe even one that I would make.
Let's talk about applications. Where is Zig used today?
One application that comes to mind would be Ghosty. So this is a terminal emulator created by Mitchell Hashimoto. This is a
another
really
T
nice
in the name of that
project
project
written
that
in
they
Zig
left out.
because the code is very high quality. Mitchell does a really good job managing the
Unless it
community and
renamed.
fuzz
It's
testing and
GhostSticky
making
Y.
sure that it's good quality. There's also Tiger Beetle. Tiger Beetle is a financial transaction database that's written in Zig, and they batch operations together to achieve a level of efficiency that is not common in that space because other solutions are trying to use PostgreSQL or some kind of relational database like this and building the OLTP on top of it. But they have built a special purpose database that's 1,000 times faster than that kind of strategy. That project is really focused on pre-allocating resources and then never failing after that point. So when you start that project, when that database runs, it will pre-allocate all the memory it will ever use, and from that time, it will never dynamically allocate anything ever again. And then that keeps their latencies very predictable and very consistent for that database. So that's a good example of where using Zig was a nice choice because Zig offers you the choice between optimizing for low latency, predictable latency, and what I would call the opposite of that, which would be kind of garbage collection, high throughput, if that makes sense.
What about Bun?
Bun is a JavaScript engine that uses JavaScript core and a bunch of other C++ libraries, and then all the glue code is written in Zig. That project was recently sold to Anthropic, I think, and we've seen a lot of people consequently getting into using Zig for AI.
I also heard that Uber is using Zig.
Yes, Uber is using the toolchain. Uber uses ZigCC
Yeah,
to build
Twitch CD.
some of their things to cross-compile for ARM64. And specifically, they're using it with Go. So they have a bunch of Go code. And the problem is that when you try to cross-compile Go code, that part works. But when you try to cross-compile Go code with also C code in it, that does not work with Go out of the box. But you can actually just use Zig as the C compiler along with Go. And then now you have cross-compilation also for your C code that the Go code depends on.
By the way, why is it called Zig?
Why is it called Zig? I wanted a short word that had 0 Google results for programming language. And that was true at the time. So if you search for Zig programming language, when I named it, there was 0 results. So I made a little Python script that just printed some random words, and Zig jumped out at me, so I picked it.
Why do you have the iguana as a mascot?
It's a Ziguana.
Ziguana. Amazing. Well, Andrew, Zig is in top 5 most admired programming languages. But no 1.0 release after 10 years. What's blocking it?
Well, ultimately, 1.0 can mean different things for different projects. So if we look at Go, they tagged 1.0 and they did not touch the language for a very long time. Rust tagged 1.0 pretty early, but they have this feature called additions. And so even though they maintain the backwards compatibility guarantees with 1.0, they still can change the language quite a bit. And writing modern Rust is still different than writing 1.0 Rust at the time. So really, what is 1.0? It's a backwards compatibility promise, right? The other thing I would say about that is Zig Software Foundation is not a startup. We don't have any investment money. We don't have investors breathing down our backs. We're a 501c3 nonprofit. We don't have to crash and burn. We don't have to sell. We don't have an exit plan. Our plan is to make a great project and keep improving it over a long period of time. We have the time to make steady improvements. We're a very lean, very efficient, small organization. We don't burn through a lot of capital very fast, and so we're here to stay. We will keep improving Zig until we get there, and we don't have to do it prematurely. When we tag 1.0, it will be like a true, uncompromising labor of love. We will not have to be stuck with any bad decisions that we had to rush to lock in.
Well, I'll continue asking about that.
Okay.
Like, there is a concept in software development called worse is better. Like, ship fast, fix later. Like PHP, Go, they did that. And they became huge. So you choose the opposite. Why?
This the worse is better is a pet peeve of mine because linguistically it makes no sense. So I think I think it's better to say doing less with less versus doing more with more. I think Zig is a third option. We're trying to do more with less. So we still want to offer great things, but we want to find that sweet spot where a little bit can go a long way. And you can find this reflected in the language with, for example, the ratio of a small amount of complexity of comp time feature to the high amount of utility that you get from it. And you can find that reflected in the tool chain where just one flag can tell the compiler to target a wildly different operating system and architecture, and that will just work.
Do you think missing 1.0 caused Zig users or company adoption?
I think it's no doubt that when we tag 1.0, we will see a sharp rise in adoption. That's certain. But for me, I have my eyes on the long-term future. I want to make Zig to be a language for the next 50 years. And I think we will start to see those pay off in this upcoming 0.16 release.
Can you share us maybe deadline for that?
Yeah, this one, oh, how about this? We can make this a race, okay? So you race to try to get this video uploaded, and I will race to try to tag 016, and we'll see who wins, yeah?
To develop the
wonder
language,
who
you
won.
founded Zig Software Foundation. And in 2024, its total income was $670,000. Who are your main sponsors?
If you look at the blog post where I presume you got this information from, there's a nice pie chart that shows the different parties that our income comes from. And I'm really proud of how diverse that chart is. A lot of our sponsors are individual donors. And then apart from that, we have a nice, healthy variety of different companies that we get donations from. So we don't have any single entity that can say, hey, you need to do this or this. We could turn to any individual sponsor and say, I'm sorry, but we will not do what you say, and if you take your money away, we will survive. So it's a very mutual beneficial relationship, but just with healthy boundaries between the business organizations.
Can someone of your sponsors influence how you develop Zig?
Well, they can influence it in the same way that anyone can influence it. They can participate on the bug tracker. They can send pull requests. They can chat in the development channels. And ultimately, it's humans talking with humans. They don't have a secret high priority channel. Everyone's on equal footing here.
Your salary is $154,000 per year,
Yes.
which is comparable to a senior engineer. But you are building an entire language ecosystem. How do you decide on your own salary?
Zig 0.16.0 was released April 14th. So 7 hours ago. Looks like Andrew won. Thanks for doing the research, TwitchTD. Also, they say his salary is $154,000, which is comparable to a senior software engineer. I don't know where that's based on. Like senior software engineers all over the world make different amounts. I think Andrew's American, but even within the U.S., a senior software engineer in Florida is going to be making a different amount than senior software engineer somewhere else, like Los Angeles. Also, where did my mouse go? That's fascinating. Wonder if I have, I wonder if my mouse disconnected. No, battery didn't die because it's plugged in. I don't have a wireless mouse. But I do have unreliable USB sometimes. So one sec. Mouse back? No? Oh yeah, I don't have a keyboard going either. And now we're back.
This was decided.
Yeah, I have a USB switch to switch between two machines, my mouse and keyboard, and sometimes it's just a little unreliable. I just gotta switch it to the one machine, then switch it back, and then it works again.
By the Zig Software Foundation board when we had our first board meeting. And this was the median senior software engineer salary in New York City at the time, which is where the nonprofit was formed. It seems like in your question, you're implying that maybe I deserve more money, which thank you for the implication. But honestly, I feel upper middle class. I feel like I get a lot of money and I can afford groceries easily, and I can afford to mortgage for a house in Portland, Oregon, where I live. So I'm comfy, I don't need more. And I like to me, the autonomy of having a lean nonprofit that is sturdy and can withstand a chaotic financial environment that we are in today. To me, that is more valuable than having some more spending money, because this is what allows us to say, no, not yet. We need a little more time for 1.0. This is what allows us to, this is what allowed us to raise the rates for our contractors in a year where everyone was having massive tech layoffs. And I'm proud of that. I think that what we have is a healthy organization, and to me, that benefit it fills me with satisfaction that having more income would not fill.
And if a large company offers Zig, say, $100 million with no conditions, would you take it?
$100 million. So to put this in perspective, our yearly annual revenue has been less than $1 million every year. Maybe is starting to approach it this year. So there's two limitations here, I would say, to this money. The first thing is sustainability of the nonprofit. So what I would not want to do is take that money and then spend a significant fraction of it, and so that I would need to get more of that amount of money in the future. That would be a problem, because now whichever.
Yeah, I mean, he's spending less than $1 million a year on his salary and paying for all the contractors and legal and everything like that. If he were given $100 million, then that's 100 years of operating at the current capacity, where he doesn't need to worry about raising anything more. So he's right that if they then start spending a whole bunch and everybody gets paid 4 times as much, then all of a sudden you just start burning through all that money. That ends up being a problem. When you come into windfall like that, best thing to do is to not increase your spending, is to just sit tight.
Instead of a surprise, a gift, now we need it. Now we have an obligation to try to get it again. And then the second limitation here would be team size. I'm managing a team of 5. I don't think I have the skills to manage a team of much more than that, nor do I have the motivation to do it. I would certainly not take this money and then just grow and become a manager of 100 people or something like this. But what I could do is, if it's $100 million, I could take that money, put it into the bank, and then never have to fundraise for 100 years, So sure, it'll take the money, but not grow. You see what I mean?
I see.
Because I think that what the question is fundamentally asking is, would you grow if you had the opportunity? And I think the answer is a little bit. I think we could have more than 5 people, but I think maybe more than 10 would be pushing it for me.
So a team of 5, your salary, is that like all the money from the foundation?
The foundation has 1 employee, which is me, and then 5 contractors. We have other contractors who are not active, but about 5 who are paid full time. And I believe the number was 91% of that money last year went to paying contractors to work on the project. So the vast majority of the income that we get from donations is going directly towards paying contractors for work on the Zig project.
Being this open with the money, is it because some obligations that nonprofit has, or it's something important to you as well?
There's some obligations that nonprofits have. So this is a United States 501c3 nonprofit. And I'll take this moment to point out that it's different than a 501c6. That the 501c6 is a business league. That's what the Rust Foundation is. So, Amazon, Netflix, Microsoft, Meta, they all have a shared interest in the Rust project succeeding, so they all donate to this 501c6 so that it can help them lobby the government and do all these things. 501c3, not allowed to lobby the government, and we don't have other businesses that are in interest. It is serving the mission statement alone. That is the purpose of the 501c3. The blog post where we break down this income and these expenses and share more of these details, that's voluntary transparency. But that also acts as marketing for us because we do good on these metrics, so it helps people to have confidence that we're doing a good job. And it serves as an opportunity to fundraise as well.
In 2022, you left Reddit and Twitter. Why?
I think that posting on these websites is becoming a lot like posting on Slashdot or Dig. They're just becoming kind of irrelevant anymore. We're software engineers. We want to do as little marketing as possible, and so these things just aren't giving us returns on our investments anymore. We're starting to do more in-person events like Zig Day, and as opposed to social media where we interact with trolls or just the algorithm controls what gets seen and what not. This is what we're currently thinking is a better investment of our focus to grow the community.
Then, in late 2025, you took another step. You moved Zig's main repository from GitHub to Codeberg. Why?
GitHub simply stopped working for us. We would not have results for our continuous integration runs anymore. It just would stop working. So we moved to Codeberg, and now our continuous integration server works again.
But you had sponsors on GitHub. Did they follow you to the new platform?
That was a tough choice to leave those behind because, any time that funding is concerned, it's a bit spooky to potentially take a risk and lose a source of income. But ultimately, we're here to write software, and if our continuous integration server doesn't work, we need to find one that does. So that was the highest priority.
Did the foundation lose some money?
We're doing completely fine on that front. We're creating software with the MIT license. This is a no strings attached donation, if you will.
I think it's quite a complicated decision to leave GitHub. I remember reading about this when it happened, and if there are technical issues that are getting in the way of Zig running their CI, there are third-party CIs that could also be hooked into GitHub, or the repo could be mirrored, or there are other ways to do this that are not just the sort of the political statement of leaving GitHub entirely and saying, oh, okay, we'll wash our hands of this, we're done. I think when when Andrew spells it out here, it sounds like a very technical thing, but I remember when I read it, the posts that were involved with this, it sounded a lot more emotional to me. And I don't know, I mean, GitHub is the place we go to for open source. And that's still the case, even with GitHub suffering all of the stability issues that it's had recently. GitHub is still the central hub for open source. So a language like Zig, a fledgling language like Zig, loses a lot from leaving GitHub. Yeah, at least you could easily maintain a mirror like you suggest. Yeah, like having people need to sign up for, another Codeberg in order to create issues or pull requests or whatever, like there's so much that is just ingrained in the open source community that is tied to GitHub that to me, it just doesn't feel like a good move for the longevity of the language. Like I want Zig to succeed. I want Andrew Kelly to succeed. I think that even though Zig doesn't line up with the type of language, it lines up with the goals. I think it has a lot of the goals that I would like for a systems programming language. It's not the same goals that Jenk has, but if I were just doing systems programming, because Jenk is not a systems programming language, if I were doing systems programming, then I would want a language that has those goals. And I love the work he's doing with cross compilation, everything like that. So I want him to succeed, and I just don't like. I hope he can still succeed while not being on GitHub, and I expect he will. But I think that leaving GitHub is a big setback that, from my outside perspective anyway, seems like it didn't have to happen. I think you get a slightly different crowd, and then it's maybe more aligned with the people that work on Zig. Yeah, so that's a fair point, D309. Like maybe he's kind of, because we haven't gotten into the AI bit yet. Where Zig is clearly like no AI policy and everything like that. Maybe he is cultivating the culture in his community by doing this and saying like, yeah, the type of people who are willing to go on to Codeberg, those are the types of people that we want in the community. And if so, like, sure, he's really cutting out a lot of the mainstream open source devs. But maybe he's making it for that niche that he's cutting out. Maybe it's the people backing it will be even more behind it. But yeah, for Jenk, I don't imagine that we would leave GitHub, even if we end up with like all these technical issues, because I would just like, I mean, we can solve technical issues. GitHub it's unlikely, from what I've seen anyway, to get in the way so much in the way that we just can't solve the technical issues. It ends up being more of a political thing, and I don't know. Maybe it's because Zig is certainly further ahead than Jenk. Maybe they're just more confident, more stable on their own feet.
To the world of software. And people who donate money to us, likewise, are making no strings attached donations. Under this relationship, I've found that there's a high amount of respect for the other party. So, if someone stops donating, I don't say, hey, you jerk, why did you do that? No, of course not. It's no strings attached, right? And when we make these choices to move off GitHub or do this or that, I find that people are very understanding and very gracious.
By the way, why Codeberg specifically? Not GitLab, not hosting your own server?
Codeberg is essentially a clone of GitHub, so it was an easy transition to make. Codeberg is also a German nonprofit, and personally, I find using nonprofits to be a more stable businesses than startups or corporations, because these corporations are always chasing the next thing and trying to make the next quarter more profitable or something like this. And the nonprofits are just trying to keep doing what they're doing, and that stability is what I want in CodeForge. So that was why I picked Codeberg.
Leaving social media, leaving GitHub, it all sparked huge discussions, huge debates in the community. Like, many say that this will stop Zig's growth, maybe turn Zig into a niche language. What do you personally think about that?
I think that the CodeForge is not really a marketing arm of the project. I don't think that people are discovering Zig through GitHub or Codeberg. I think they're discovering it through, like we were talking earlier, about talks, meetups, stuff like this YouTube video that we're making right now, Zig Day meetup groups. These are places that people find out about a language. Whether we use Git or Mercurial or where the bug tracker is, I mean, they affect how convenient it is to work on the language, but that's not marketing, you know? So I think that this idea that it's some kind of crisis of popularity, I don't understand.
Yeah, so I mean, he's kind of addressing what we're talking about here, but DJ Blue, for one thing, I gotta say that submitting patches via Jira is still the most awkward way to contribute, for sure. Yeah, Clojure probably takes the cake in terms of making it hard to contribute to a language. But on the topic of contributing, there are a couple of different things. So Andrew's saying here, like, well, people aren't generally going to find Zig on GitHub. They're going to find Zig from hearing about it from a friend or seeing a video about it or going to a meetup or whatever. And that's a fair point. But there are multiple factors when it comes to the growth of an open source project. So one of them is just how many people know about it, how many people use it. But another one is how many people contribute to it. And that is where not being on GitHub is going to have a measurable impact. If you're on GitHub and somebody finds an open source programming language like Zig or Jank or whatever, and then they're like, oh, well, I'm really good at optimizing compilers. Let me go change this thing and share my work here. Then that's something that Zig can benefit from, that everybody can then benefit from. And this sort of thing happens just over and over and over again. Every day you have a new opportunity of somebody stumbling along and deciding that they're going to make a pull request that you may be interested in. And that becomes like there's friction introduced on that pipeline when you're not on GitHub. And maybe this will change. Like maybe, like I like that Codeberg is a nonprofit. I didn't know that it was. And so Andrew's doing a great job sort of spelling that out here. Maybe that will sort of shift and things will be less focused on the monopoly of GitHub, in which case, like, that sounds like a kind of a cool future. But as it stands today, yeah, it is bold to be one of the pioneers leaving GitHub and forsaking all of that sort of lack of friction that we have within GitHub. I think Codeberg is actually getting pretty big. Maybe I'm just in a bubble. I feel like it's got to be a bubble because there's no way that non-GitHub, I'm not even going to say Codeberg, I'm just going to say non-GitHub. And that's going to include like GitLab and Codeberg and whatever others that I can't think of right now. It's just going to include everything other than GitHub. There's no way that for open source development that those account for even 10% of like popular projects. There's no way that they even account for 10%. I will be surprised if it's even 5%. But the thing that matters more about that, I suppose, is the growth. Because when you take a look at something like Linux gaming on Steam, I'm pretty sure that Steam users right now, the percentage is about like 5% of Steam users are on Linux. And that doesn't sound like a lot, but I get excited about that number because of how much that number has grown. And so maybe if it's really trending upward, and it might be, then it holds promise. But certainly for now, like the vast majority of people are just on GitHub.
Understand the reasoning behind this at all, really.
Let's talk about some things around Zig that have sparked a lot of discussion. You moved away from LLVM. Why?
I play a 10-player competitive arcade game called Killer Queen. And it's quite fun, but the developers made the choice to use Unity for their physics engine. And the problem is that physics engine, the physics engine is extremely load-bearing for competitive play. Even tiny little changes to it will make it competitive players feel completely different and reset their skills. And so these developers, they can't even update to the new Unity version because even the bugs fixed in the physics engine will cause an uproar in the community of people who play this game. So they made the mistake of using a dependency for their core product. And I think that that's a key insight, is that you want to avoid a dependency for your core product. And we have done this with LLVM with Zig. And so we're in the process of rectifying this mistake. So I think of it like training wheels on a bicycle. I've been working on Zig for over 10 years now, and I know more about compiler development than I did 10 years ago. And so I can take the training wheels off, and we can compete with LLVM at this point. And so by owning our core product dependency, or by owning our core product and not having a dependency, this has enabled us to unlock things that we could not do before. So for example, when you're using our own x86 backend, we now have incremental compilation that brings even massive million-line code bases down to 50 milliseconds or less with changes. You make a change to your code, you have a new binary already updated, 50 milliseconds. Million-line code base. And this is simply not possible with LLVM. But this is something that we can do now with our own code.
Zig has a strict no LLM, no AI policy for issues, for pull requests. Why?
The first reason is,
So before we get into the AI stuff, I've thought about this so much with Jank as well, because like Zig, Jank is starting out very much relying on LLVM. And unfortunately, unlike Zig, I don't think that we can get away from it. Because Jank has such a strong interop story with C++, we rely on Clang and the Clang AST in order to compile that C++ and then allow us to use that AST in order to do overload resolution and implicit type conversions and template instantiations and all these things. In order for us to move away from Clang and LLVM, we would need not only our own JIT runtime, but we would also need our own C++ compiler. And at that point, we're building a closure dialect and also a compiler backend for lowering our IR down to machine code for whatever platforms we're supporting, let's say x86, 64, and ARM64. And then also a JIT runtime for being able to then like load all that stuff into the current process. And then also a C++ compiler that supports all of the modern C++ stuff. So Zig had to build the compiler backend, and so we would have to do that. But then we would also have to, like, if we wanted to just, as Andrew's saying here, like not have a big dependency, but instead own everything ourselves, we would need to build a C++ compiler as well. And that's just not viable. Like, there's no way that's going to happen. There's no way I want to do that. Even if, let's say, even if somebody who's paying me to do it, well, if somebody wanted to pay me $100 million to do it, then I'd be like, okay, if you say so. But yeah, I think realistically, there's just no way that that's going to happen. So it's possible that we could get away from Clang and LLVM. But we would still rely on some C++ compiler. And when you look at, and we have to use that C++ compiler as a library, because we need that in order to be able to do all the seamless interop stuff that Jenk does. And as far as my research has shown, the only C++ compiler that's actually usable as a library is Clang. So GCC is really not, it was not designed to be used that way. There's a lot of historical discussion around this and some pretty funny stuff as well. That was the story. There is apparently an email was sent to RMS, Stallman, and the email was like, hey, what do you think about making GCC into like a library type thing? And Stallman just claims that he never got that email, or that like he didn't read it until like long after the decision had been made, and so now it's just kind of too late. And so if only he had read that email and responded saying yes, then maybe GCC would have ended up in a very different situation where it can compete with Clang as a compiler, as a library. But as it is, now it can't. And so, yeah, even getting away from Clang to some other C++ library, C++ compiler library is just not viable. Yeah. Yeah. So Zig's a little more fortunate there. Jenk's a little more boned. But they're very different languages as well. Very different languages.
It's just that those kinds of contributions are invariably garbage. People are sending us contributions that have no value whatsoever. Not only that, they have negative value because they take review time away from the team, which is very limited. We have over 200 pull requests sitting open right now, and those are all waiting for review. And we try to be on top of it as much as possible, but when you have a small number of people in the dev team and you have a large number of contributors, this is always the problem, is this bottleneck of review time. So when we get these slop contributions, they take our review time, and then after a few reviews, we realize they have no clue what they're doing. They're just pasting what we say back to the chat and then laundering the chat back to pretend that they're not using chat, but we can still tell. And then at some point we realize this is never going to be a good quality because they have no idea what they're doing. And so now we wasted everybody's time. All those other people who were waiting patiently, they didn't get a review, and the code never gets merged. It's worthless. We like to call it contributor poker. So the main point of doing code reviews and having contributions, instead of just doing all of the work ourselves, is mentorship. The whole point is that a contributor can become a core team member eventually, or they can become a more valuable contributor. And this will help the project because we'll have more people who can contribute to Zig skillfully. And it will help their resume because they can be a better systems programmer and they can take those skills elsewhere. The idea of contributor poker is that we have limited time, so we want to notice, okay, who can we invest our time in to help them become better programmers, better contributors for the project, and who is maybe who is maybe a drive-by contributor. They're going to send something, they're going to go away. Less valuable to invest in them. And so people who are using AI, they're always in the second category. It's not worth it to invest in them. They're not learning anything. They're not going to join the core team later. Not a chance. For us, this policy just makes sense because the Zig project, it's also an education project. That's part of our mission statement, is we're providing guidance and education to students. And so we're all trying to learn. We're all trying to get better at programming. And so people who are sending AI pull requests, these people are not helping this goal. And in fact, I think that they're detracting from this goal. So for our project, I think that the strict no AI policy it's an appropriate policy. You know, if I tried to say, oh, only good AI PRs can come in, now I have to be the judge of that. Whereas if it's none whatsoever, then it's a very easy policy to enforce. So.
By the way, how do you detect AI-generated content? Is it easy?
It's not always easy. I'm sure that some have gotten through, some have gotten in. And lately, I think they've been laundering the LLM text. You know, they don't copy paste it directly because that's way too obvious. So they try to rewrite it in their own voice or something, or they say try to sound human or something like this. I've reviewed so many pull requests, you know. So at some point, I realized this is not what a human does when presented with this feedback. And then it becomes obvious. But it's pretty relentless lately, so I think we might need to have a different strategy than the current policy, which allows anyone to contribute. I think we might need a more strong filter for getting in and getting the permission to send a contribution, unfortunately.
Zig Codebase uses the MIT license. So what's that?
This is such an interesting challenge that we have now in open source, where you get new contributors, and you want to encourage new contributors to come along. You want to Andrew is talking about the mentorship possibilities. So you want to try to sort of encourage your contributors to stick around and learn more and contribute more and get better, so that then they can become core team members. But you need to build trust along the way, and you start out with, at this point, like no trust for like a new person who comes in and gives you a pull request. And so how do we manage this? Do we manage this with like a vouching system or some sort of like social credit system to say like, oh yeah, I know Sally, you know, I've worked with her and I'm a core member, and so she's able to get in and start contributing pull requests and getting the review time dedicated for that. But then that can help in some cases, but what happens when you actually get somebody who sincerely wants to help and is doing all of the hard work and is doing the learning, and but they don't have the networking credit to be able to say, yeah, I know this person, I know that person. How can they show that they're worthwhile for the time? I've thought about this in the context of trust and social credit for things like supply chain security as well, where it's like if somebody has a library that they've uploaded to do a certain thing for a language, how do you know that that library is any good? How do you know that it was vibe coded or that it was manually coded? And how do you know anything about the person who created it? And like, we don't have a good solution for that right now. In fact, like we can see this being a problem with NPM and all of the issues that have been shown up with that recently. I think there may be some interesting ideas around like a social credit system or like a staking system, you know, where like, what if you end up this is just a spitballing idea here, but like, what if there's a vouching system where or not a vouching system, but a staking system where you actually have to like stake some, I don't know if it's real money, like could potentially happen with, you know, with real money, or maybe it's some sort of like social credit that you build up through various means, where you actually have something on the line when it comes to uploading open source software or submitting pull requests or sharing libraries with people on various package management repos, where you're saying like, look, I'm invested in this. I didn't just upload something hoping that people would download it. I uploaded it, and I'm also doing an extra step in order to prove that I'm somebody who's, you know, serious about this. One way would be to stake money in it. And so basically, if there's an issue found with like a security issue, if that library is found to be malicious or something like that, then that money is forfeit, because it's actually, when it's staked, it's held in escrow by, let's say, Clojars. And so, yeah, you can put out something malicious, but it's going to cost you literally. And then the more money that's on the line, and also like additional vouchers and everything like that, then the more you can trust something. I don't know. It's not a perfect system, because even that can be gamed. Even that can be gamed. People don't use LM to help them sift through a topic. They may be unfamiliar and aid them with learning instead of just generating random solution. Yeah, laziness. Have I seen this Mitchell H. vouch? Fabes asks, a community trust system based on explicit vouches to participate. Yeah, I think I have seen this. Yeah, maybe we need something more like that, Fabes. What do you think? Because we need, I mean, this applies to multiple different situations. This applies to the situation like this, where you have an open source project and you want to know who to, like whose PRs to actually put time into. But then there's also the whole like, okay, I want to download a library for interacting with such and such API. And there are a whole bunch of them on my, you know, package manager repo for my particular language. Which one do I use? Oftentimes you look at like the GitHub stars or whatever that exists for that. Also doesn't work if it's on Codeberg or some other sort of thing. But having some other sort of way of seeing how trustworthy some software is would be really helpful. And I want to solve that for Jank. I just don't know how to. I don't know of an airtight solution anyway. Seems like everything can be gamed.
It's very close to public domain. For people unfamiliar with software
MIT they're
licenses,
talking
it's
about.
effectively public domain.
So, like, can you give an examples how it can be used?
It can be used almost for anything. The only restriction that the MIT license makes is that you have to reproduce the license if you are copying the code. And you can't hold us accountable for problems that no warranty, basically.
This means anyone, like including big companies, can use your code to train AI. But at the same time, like you ban AI from contributing to Zig. How do you feel about this contradiction?
It's ironic, isn't it? Personally, I have no issue with this. I really firmly believe in the no strings attached gift that Zig is to the world. If someone wants to use Zig for AI training, great, I don't care. That's fine. The fact that these companies are doing things that I don't like that they're doing it, but it doesn't bother me that they're using Zig. I think that the more that Zig is being used, it just shows that Zig is valuable. That's the way I see it.
Is it true that LLMs struggle with Zig code compared to Python or JavaScript?
I haven't tried it much myself, but my understanding is that it's actually just fine. So I know that Mitchell Hashimoto uses AI coding extensively for Zig with Ghosty. Another person I know, his screen name is Rockeregger. He made a tool that makes AI work better for Zig, and he's having success. He's reporting success with Zig. I've seen some people say it doesn't work well. I've seen some people say it works perfectly fine.
I recently read your
In my opinion, AI generated code always feels low quality. Oh, Polymarket, is this PR AI? Hey, Kyle. Hope you're doing great, man. Yeah, I don't know. I don't know. Maybe that's not really a great staking social credit vouching system. That's just like everybody throwing more cow patties onto the dumpster fire. I think it's an interesting idea and approach, but also gaming is always something to be aware of for sure. Mitchell Hashimoto is a figure in the Zig space. That's why I mentioned his vouch. Oh, that's his vouch. Gotcha. Yeah, I'll take another look at that, Fabes. I think it's if it is a like social network type vouching, as in I know this person, let me vouch for them. That's cool, but I wonder how they handle like the genuine person who shows up and doesn't know anybody. I don't know. Maybe we'll take a look at it after this.
your Mastodon post. Vibe coding blogs are a snooze fest, like reading restaurant reviews instead of watching the chef cook. What do you mean? And what's your opinion on vibe coding?
I love computers, and I love learning about what people are doing with them. And there's a sense of mystery and magic that you can get from reading someone's explanation of a project that they did that took them a very long time, and they had to learn lessons, and they had to increase their skill as a programmer and as a user of computers in order to accomplish this goal. And when you read a blog post like this, it's brilliant. It captures the imagination. It makes you think about what you could do yourself. It teaches you something. It connects you to them emotionally. But I mean, on the other hand, we're seeing people say, "Oh, I tried this version of Claude or that version of OpenAI, and sometimes it worked surprisingly well." I'm always hearing people say that AI code works surprisingly well, but to me, this is not the bar that I want to hold software to. The bar that I want to hold software to is uncompromising perfection. I don't want to be surprised by the absence of a bug. That's a horrible quality bar to believe in. So, I mean, it's just so many people saying, I don't know, I tried coding this app and it kind of works. Okay, It's just so uninspiring.
But have you tried vibe coding yourself?
I I did a call. I did a private call with Richard Feldman, a friend of mine, and he showed me how to use vibe coding with Zed, and I tried it out. And um, I thought that I think that the technology is fundamentally interesting. What really turns me off is the fact that it's centrally controlled by, I don't know, 4 companies, and they have total control over what it's doing. They have total control over the models. I mean, I'm not going to go from using my own computer and my own electricity to do my code in order to use closed source programming on someone else's computer through the network. This is that I have to pay for monthly. I mean, some people are paying $300 a month for this. To me, this is an insane proposition. I would never want to give up what I have in order to get.
I think it's interesting that Andrew says that his big issue here is the fact that that these models are proprietary technology that is running on someone else's machine. Because I would be surprised if that's actually his biggest issue with it. I could just be projecting because that's not my biggest issue with it. But like as he was just describing with the pull requests and just all of the AI slop that people are submitting to Zig, that whole problem would still exist with open source models. Let's assume hypothetically that there's an open source model that's just as good, if not better, than any other model that is proprietary. People are still going to be using that to create slop blog posts and slop pull requests and slop in general, slop. So that says to me that the main problem is the culture around using this to create software and thinking that that software is in equal standing with software that is actual engineering going into it. Like to me, that's what I would say the problem is. I would imagine that that's actually what Andrew thinks as well. But I guess we'll find out once we have open source models and people keep using them to generate slop and submitting it to Zig.
The results of Gen AI.
In general, how do you feel about the future of programming? Like in 10, 20 years, will humans still write code?
People will never stop writing code because writing code is really fun, you know? It will always be, at the very least, a hobby. And I will say, on my phone, the apps that I use, and on my computer, the apps that I use, the very best ones are the ones that were made by people in their free time for a hobby. The ones that are made by companies that I have to use because of whatever reason, I feel like I have a hostile relationship with these apps. They're always trying to get me to buy stuff or advertise to me or coerce me into doing some kind of engagement metric that they've decided that they care about. But whenever I use an app that was made by someone as a hobby, it respects me. It treats me as the boss of the computer, and that's the relationship I want to have with my software. And so that will never go away. People will always want to make software for a hobby. People will always want to make free and open source software. People will always want to have the relationship with their devices where they're the boss. That will never go away, no matter how much these companies will try to become the bosses of our own hardware.
Yeah, so you've mentioned those projects. Like, you often criticize bloated software. Like, what are your top 3 software projects that you actually admire? Like, what makes them great?
Well, number 1 would have to be Linux. It's maybe hard to imagine a world in which we didn't have it, but it would be, a world with only proprietary operating systems would be significantly worse, I think, than the one in which we get to enjoy Linux. And I think we can all agree that Linux has been not only incredible for free and open source software developers, but it has also been a boon for just economy. Just
Oh yeah.
countries around the world, businesses around the world being able to build their businesses on Linux for free is really good for the economy. So however you want to look at it, from a hippie perspective or a fiscally conservative perspective, it's really good. Next, I would say Blender. So Blender, I really respect Blender because it's used professionally. And it's an open source project where it's competing with companies that have a lot of money, a lot of software development labor to spend on the problem, and it's winning. And it's open source software. That's brilliant. And it's also a nonprofit. And the third one would be VLC. VLC, another nonprofit organization. I think that if I remember correctly, the president is still JB. I met him in person in Paris. And I think that is a really well-run nonprofit. Earlier on, when I was just out of college, I contributed to FFmpeg, which VLC uses as a dependency. And the VLC organization paid for the travel to go to Videoland Dev Days for anyone who had contributed to VLC or any of the libraries it used. And so I was this kid, and I got to go to Dublin and Paris for Videoland Dev Days on that nonprofit organization's dime. And that was an incredible experience that I got to have there. And I was really impressed with how JB handled the organization. And I mean, who doesn't love VLC, right? Everyone loves VLC.
I used to teach Blender to kids many years ago. Of course, I'm using VLC. And also, our showrunner noticed that you use the Firefox browser on your streams. Like, I use it too, but she was very surprised. Why Firefox?
I'm a little concerned with how few browser diversity there is. So after Microsoft killed Internet Explorer, I mean, good riddance, I guess, but now there's only Chromium, Safari, and Firefox left. And Chromium has like the vast majority of the market share. And I think that's a problem for the web. I think it's a pretty uncontroversial thing to say that in general, monopolies are bad. And having a monopoly on the web browser would be worse for users than if there was healthy competition. So originally, I just picked Firefox because it was the underdog. It's a nonprofit, and that's I don't know. As a user, that's my contribution to trying to not be part of the Chromium monopoly. But I have to say that lately, I've been not very happy with Mozilla. Even though it's a nonprofit, I think it's an example of one that has a lot of corruption, and their alignment is not with their users, it feels like to me. That's an area where I feel really frustrated because there is not really an alternative. Chromium is Google, Safari is Apple, and then we have Firefox, which seems to be in a tailspin. So I don't know what to do about this. There's some new browser projects being made, but until those come to fruition, I don't know what to do.
Andrew, Zig is sometimes positioned as a C replacement, but C is everywhere. Linux kernel, embedded system, 7 million of developers. What makes Zig better than C?
Zig is better than C because Zig does not give up any of the power that C offers while improving the flaws and the weaknesses that C has. The other attempts to replace C always give up something that C has. So I think a good example of this would be Go. The Go programming language is really nice for writing server software. It has HTTP in the standard library, that sort of thing. But there is a whole class of tasks that you can never use Go for that you can use C for. So it's a trade-off. You had to give up something to get those nice things with Go, for example. So that's why Go is not a C replacement. With Zig, you have not given up anything. Anything that C can do, Zig can do, and it can do it better, and it can do it with less footguns, and it can do it in a way that's more debuggable if you run into a problem. In a way, Zig embraces C more than C embraces C. C only has optimized integers for signed integers, and C only has wraparound semantics for unsigned integers. In Zig, you can have whichever one you want. You can have wraparound unsigned or unsigned, and you can have promise no overflow unsigned or unsigned. This is just a glaring missing feature from C. It's a lack of power that C has. So Zig is actually offering you, arguably, it's being more C-like than C is, if that makes sense.
But is it even possible to replace C?
In order to replace C, you have to beat C at its own game. You have to offer people a way to write code that is reusable everywhere. So code that can run in an operating system kernel, code that can run on embedded devices, code that can run in video games, code that can run in WebAssembly. This is why C sticks around. If we provide these features and we become as stable as C, then people will make the right choice. They will choose what works better. They will choose what is better performance, leads to fewer bugs, but they will never give up what C has. And so that's why I think that Zig will succeed in replacing C, because we did not give up anything that C has.
How Zig is different from Rust?
The core feature that's different from Zig and Rust is the type system. So Zig is a simpler language than Rust in the sense that the type system does not have a meta language that describes what types are allowed to pass to which functions. So in Rust, when you have a function and you take a parameter, you have to say, okay, this parameter supports cloning, or it supports this interface or that interface, and you have to describe in entirety the rules about what you can pass to this function. And Zig does not have any of this machinery. So in Zig, you have to pass a concrete type, or you have to pass a generic type, like templates. They work like templates in C++ in the sense that the code will get substituted with what you pass in. So that's a trade-off. So with the Rust code, you're going to have more guarantees about the type system, and with the Zig code, you're going to have more simplicity in the code that you're reading. But beyond,
I think the way that I've put it before is that like Rust is kind of the modern version of C++, and Zig is kind of the modern version of C in the sense of their philosophies. Like Rust has a lot of complexity, and it's just getting more and more complex. And you can do a ton of stuff with the type system and meta programming. And Zig has some compile time evaluation stuff, but it's a lot more philosophically aligned with C. And Andrew says here, like, Zig is kind of beating C at its own game. So I don't think Zig is trying to compete with C++. It's trying to compete with C, whereas Rust, in my experience, tends to be a lot more targeted at like competing with C++. Also, Ronaldo, welcome to the stream. Hope you're doing great. So Zig is C, but plus more with templates. Yeah. I think that the Zig is like, if C was already fitting your philosophy, then Zig is probably going to be a good choice because it's just a modern take on that. If C++ was what you gravitated toward instead for the additional features and control, then Rust is going to most likely be a better fit for the way that your mind works. This has been my experience as well. I haven't actually written any software in C, I haven't written any software in Zig, but I've written a lot of software in C, C++, and Rust, and then the rest is just looking into Zig.
beyond that, there's some deeper differences in Rust and Zig. So I think one would be around memory management. So with Rust is leading you down a very similar memory management style with C++. So this, people like to say RAII, and what that basically means is that you have objects. Those objects have links to other objects, and these are all reference counted. And when the references go back to 0, then things are deconstructed. And in Rust, this happens automatically, just like in C++, how destructors are run. And that's how you kind of have to manage memory in Rust. That's what the language will lead you towards doing. That's what you will not be fighting an uphill battle if you are doing. In Zig, allocators are much more explicit. So we can do this kind of reference counting style, but it will require writing this reference counting code explicitly. In reality, what we end up doing usually is a more tailored memory allocation style towards the application. Maybe we use an arena allocator to group these allocations all together and then toss them all at once, very common in Zig. Sometimes we use a general purpose allocator for this more object-oriented approach. And you can even come up with other kind of mixes of different ways of doing it for very specific applications. But this more focus on optimizing your memory layout, I feel is more of a Zig programming language feature than it is in Rust. In Rust, you're more tied to this object-oriented lifetime strategy. If that makes sense.
That's about language features, but what about maybe technological domains? When would you choose Zig over Rust?
You would choose Zig over Rust if you want to have more control over exactly what your code is doing. In Rust, you're going to try to make your source code match the Rust way of organizing.
I think he's saying like Zig is closer to what the machine's actually doing because Zig is actually a lower level. Like Rust has more abstractions, and so Rust has the concept of iterators, and you will, like, and iterators are understood at the compiler level. And so you'll write your your code in terms of iterators, and then you'll just trust that the Rust compiler is going to generate good code for you. Whereas in Zig, like in C, you're working much closer to the actual machine, and so this gives you a lot more control and a lot more transparency in terms of the work that's actually being done. That's my interpretation of what he's saying.
Modeling reality. You're going to try to make the borrow checker happy. You're going to try to create traits that satisfy your constraints, and you're going to try to satisfy the type theory of everything. In Zig, you're going to think about, what do I want the CPU to do? And then you're going to write the code that makes it do that thing. And so if you have this latter mentality, then Zig will be a more natural fit for programming than Rust.
What's Zig's killer feature, and why?
The killer feature is the toolchain. When you use Zig, you're using a software suite that has no dependencies on the system. So it will work on any operating system that you choose, and you will be able to target your code for any operating system that you choose. So you have independence from the system that you're running on. So one thing that I like to focus on as a measure of how easy is it to hack on a project is it's the README check. So the steps to contribute in the README. What do I have to do? Do I have to install a bunch of packages from my system? Is it different depending on which operating system I'm on? How many commands do I need to run in order to get in an environment? Do I need Docker? Do I need to have specific hardware or something? And for me, the gold standard is one line, one dependency, and it always works for everybody, no matter what computer they're on. And so when you use Zig, when you use the Zig toolchain, we have accomplished this. You can, if you look at a Zig project, in the README, it should say steps to compile, steps to build from source, Zig build. That's it. And that is what the Zig toolchain offers projects, is that all the contributors will need to do is Zig build, and it will always work.
Many people argue that Zig is unnecessarily strict with unused variables. Like, why are they treated as compilation errors?
That is an opinion that tends to flip the moment that the person has to refactor a large amount of code. Because the bottom line is that it saves time. That error actually saves time. Because it catches bugs, and those bugs take a long time to find, and it does not take a long time to add your annotations to discard the variables. And the thing is that thanks to editor support, specifically thank you to the ZLS team for implementing this, you can enable a setting in your editor to have your preference to have these annotations added automatically. So an annotation, I mean, it will just discard the variable if it's unused, and then take away the discard if you use it again. And you may think, well, what's the point of this? You're just getting rid of the error. But the point is that now you can have two people who are collaborating on the same code, and they both can have their preference made. Because the person who wants the errors, they can uncheck the setting in the IDE. And the person who thinks that they're annoying can check the setting in the IDE. Now, this person doesn't have to care about getting the errors. This person does get the errors, and they can both edit the same code. And in the source control, the annotations are always present.
Yeah, that's the real point there, is that even if you have tooling that automatically adds those annotations, it's going to show up in the diff when you go to commit. And so if you have a bunch of those annotations added, or even just one added, that should stand out when you go to like git add-p or whatever you do inside of your IDE. Hey, Johnny, hope you're doing great today. He had a point there. We moved off of build systems, but there was somewhere I wanted to say with regard to Jank on that. So like Zig's build system is super cool. And anybody, like Andrew just said that, like what's the killer feature of Zig? And he said it's the build system. It absolutely is. The amount of work that's been done to address the native bullshit that we have to put up with in C and C++ and Rust and every other native language. The amount of work that's been done in Zig to like make that sane is amazing. The other thing is that Zig, it actually has a Clang wrapper to aid in all of this. And so one of the things that Zig can do, and Andrew alluded to this earlier in the interview, is Zig can just out of the box cross-compile with nothing more than a flag added to your compilation. And so if you're on x86 64 Linux and you want to build for like x80, if you want to build for like ARM64 Windows or Mac OS, you can just do that. You just pass a flag, and there's your cross compilation. And that is just like so far from the user experience that we have in C or C++ if you want to cross compile. In those setups, if you want to cross compile, you first need to build your own tool chain. So you'll need to compile a tool chain that is specifically targeted for compiling at whatever that target architecture is. And so you can't use, if you're on x86 64 Linux, you can't use the Clang or GCC that you have there to build for like ARM64 Mac OS. You just can't do that. But for Zig, you can. And I believe Zig also makes it way easier to build portable Linux binaries. Absolutely. So they do stuff like so there's the whole cross compilation stuff, but there's so much more that they do. I know that one of the things that they do is that they inspect your binary to see all of the symbols from glibc that you're using. And then based on the symbols that you're using, they choose the oldest glibc version that they can. And then that is going to make your binary more portable. And there's other shit as well. Is Zig built on top of GCC or LLVM, or is everything from scratch? So, Johnny, Andrew was saying earlier that Zig originally was built on top of LLVM, and they're currently in the process of moving away from LLVM, so they're building their own backend, and the current non-LLVM backend is at this point competitive with LLVM. But anyway, so I was saying that Zig has a Clang wrapper to be able to compile C and C++ in this sort of cross-compile, like with all of this cross-compilation support as well. And for Jank, I think that that is incredibly exciting because I want to try to build on top of that, so that way you can say in a Jank project, let me just compile for this particular architecture, this operating system, and just have it work. And there's no reason why I would need to, at least I hope so, there's no reason why I would need to redo all of the work that Andrew and everybody else on the Zig team has done when they provide that Zig Clang wrapper. We would just need to make sure that it works with the version of Clang that Jank is using. So for me, like for Jank, I have two goals when it comes to introducing like third-party compiler tech. One is if we could bring in the Zig build system, so that way we can easily cross-compile and generate portable binaries for Jank projects, that would be amazing. And then two, if we can bring in Phil C, in particular Phil C++, and have that work with the Zig build system as well, then we can take Jank binaries and, or we can take Jank projects and generate cross-compiled, portable, memory-safe binaries, because we'll be using Phil C++. And then you don't need to worry about any sort of exploits in your software. Worst case scenario, they'll just panic. And that will be like, that's the dream, I think, is that, yeah, I have my native code. I can cross compile it however I want, and I don't need to worry about it being exploited. Now in the Phil C++ case, you need to worry about performance overhead. I think there's like 20% performance overhead, just kind of across the board. I don't remember exactly what the number is, but I think it's somewhere around there. But that's an option, right? As opposed to the YOLO C++ version. And I think it should be a default. So I think that if I could somehow take Jank and combine that with Zig's build system and also with Phil C++, then we would end up with Jank being a closure, but also Jank being a memory safe C++, and then also just being super fucking portable. Like that's the dream. That's the dream. I think it'd be great.
So everybody wins, and then it just saves so much time when you don't have to solve these bugs from this error.
Some developers struggle with the new IO interface. Is it too complex or just different?
I do think that I found an optimum here. So the purpose of IO streams is abstraction. The purpose of it is to write code once. Maybe you are writing an image loading library. You're writing code that will serialize to a data format. You're writing code that is supposed to be reusable. And so to do that, you want to take a parameter, which is either a reader because you're consuming data, or a writer because you are outputting data. And you want to write this code that will be independently, you can put it into a package and use it in this application, that application, and this logic can be unchanged. That's the point. The problem when you do this is you might throw away performance, because if you have your reading and your writing underneath this abstraction layer, it can be hard for the compiler to perceive that logic and do these optimizations. So I found this optimum where this interface has the buffer in the interface, and that helps the compiler to make good code while still allowing the user to achieve the main goal of reusability. I think that it is simple to use the interface, but there is a complexity in implementing the interface. That's what I think is more difficult. However, I would argue that that complexity is not accidental. That complexity is the natural consequence of finding this optimum of both performance and reusability. And that just means that this is what the implementation has to look like. So I would make it simpler if I could, but this is the way that we write reusable code that will make the computer do what you want it to do. And that is our order of priorities in Zig.
So Zig has a lot of unique features. What's the best way to learn Zig?
I would highly recommend for new users to pick up Ziglings. And I want to really thank Dave Gower for creating the project and drawing the really cute picture in the README, as well as Chris Bosch for dutifully maintaining it. That project has been consistently popular with new users. It has a series of exercises where you have almost working code, but there's a problem. And then you have to try to fix the broken program in order to learn a new language feature. And over the course of doing these exercises, you learn the entire language. So I would highly recommend for beginners to pick that up.
If you know C, is it easy to move to Zig, or is it a completely different mindset?
I think that in C to Zig is a particularly smooth transition. There's everything you can do in C, you can do in Zig, and with fewer foot guns along the way. Just a simple example is if you get a segmentation fault in C, typically you will see no output other than segmentation fault. Good luck. Hopefully you know how to use a debugger. If the same thing happens in Zig, you will get a full stack trace pointing to each line of code where you were when this happened. But you can do the same thing as you can do in C. So when C people come to Zig, they find that all of their skills transfer over perfectly, and then they find that all of a sudden they make fewer mistakes, debugging is easier, their productivity skyrockets. So that is a very particularly smooth transition, I think.
But there is a big debate in forums. Should someone learn Zig as their first programming language? So what do you think about that?
I think that really depends on the person. And some people, they have a functional mindset. They really want to learn Lisp first or something like this. I do think that Zig is a nice language to learn if you are trying to learn how computers work. You will learn about CPUs, you will learn about memory, and any skills that you pick up in Zig, they will transfer to other programming languages. You're not learning how, Zig does not have a borrow checker or something like this. You're not learning Zig rules, you're learning computer rules. And so that information will be valuable to beginners, even if they give up and decide to go to a higher level language.
What's your personal setup for writing Zig? Like, what tools do you use?
Well, because I make breaking changes a lot, or because at least I used to, I don't have a very high-tech solution. It's just the terminal and Vim. And because Vim is very resilient, if I change the syntax of the language, I can still edit the code. Some of these other advanced things, like tree sitter or something else, they require a stable syntax tree or a stable language, and things kind of will break. Or a language server, for example, things will just kind of break if you break it. So I need a setup that is resilient towards these things. But I have to give a shout out to the ZLS team because they've really done a good job filling a gap where people need this language server, and it's not something that we provide yet.
ZLS, in simple terms, what is it?
ZLS stands for Zig Language Server. It is an implementation of the language server protocol for Zig. That is a third-party project that's not run by the Zig Software Foundation. So those contributors are doing all that work of their own volition. And if you enjoy their work, then I would suggest to visit their homepage and consider making a donation or something like this.
Zig's website also recommends some JetBrains products. Have you used them yourself?
I have never used the JetBrains product because it's closed source.
What's missing in Zig ID support today? What do
So the joke here is he's never, like Andrew's saying, I've never used the JetBrains project because it's closed source, and this whole interview is like sponsored by JetBrains and is on the JetBrains channel. So I think that's also why there was a sly smile in that.
do you wish tools like JetBrains Align or VS Code did better?
Back in the day, I saw the high-level refactoring tools that things like JetBrains or Eclipse can do with Java. Things like extract to function, or reordering function parameters, or globally renaming something. Just these things that can take a lot of time to do by hand, but the computer can do perfectly and instantly with type information and syntax information. I thought that was really nice. And that is something that I eventually want to add to my workflow personally, instead of using, Vim macros or sed or something like this. I would also imagine even a more sophisticated refactoring tool, almost like a query language for making big changes across based on type information and other queues where you can make 10,000 line diffs that you're confident are correct because all of the changes verified that the type matched a certain type or something like this. Eventually, I dream of these productivity features,
One could say that AI agent can solve it for you.
but then I have to review it.
That's not based on the type system. Like that's just based on like token completion shit. I had a feeling the interviewer is going to bring that up, but like Andrew specifically said, like this would be a query language built on compiler technology, which allows you to ensure that that everything's like being matched up and replaced in such a way that the compiler was happy to start with and remains happy at the end.
Let's say that
Why have I decided to watch this interview? Well, I really respect Andrew Kelly, Johnny, and I think that in many ways, he and Zig and the Zig Foundation are like a few steps ahead of where I want Jank and the Jank Software Foundation, which doesn't exist right now, of where I want that to go. And so I watch this because I want to learn what he's up to, what he's thinking about, and then use that to inform my decisions going forward. Also, it's inspiring for me, like I think that Andrew has basically achieved the success, the exact sort of success that I want in in my language, and he's much further ahead in it, but he's not so far ahead in it that it just feels like it's like Python or something like that, where it's just been around forever. Like Zig is still like a very new language, and this foundation is like this taking in 670,000. Like that's a lot of money, but it's not so much money compared to something like like Linux or Ruby or Python. Like I imagine like these things have just been around so much longer, have so much more commercial backing. So yeah, I think it's like when you're learning a new skill, like let's say you're learning an instrument or an e-sport or a normal sport. Whenever you're learning like a new skill, it's really useful to watch people who are better than you, But if you watch people who are like professionals, then oftentimes the things that you see them do, they're just too advanced for you to grasp. And so instead, it's better to try to find people who are better than you, but just a bit better than you. And so if you're playing like a sport, then maybe you don't watch the pros, you watch the people who are in the rank above you. And then you sort of see what they're doing. And since they're closer to you in skill, you're going to be able to, one, maybe spot their mistakes. And two, you're going to say, oh, that's interesting. I wouldn't have done that right there. And because they're closer to you, you're going to be able to learn more from it. And so this is kind of a similar scenario where like Zig is one of the languages which is closest to Jenk at this point. Obviously, Zig is further ahead and far more successful in Jenk, but it's still a lot closer than most other languages to Jenk. And so I think that makes it really compelling to follow as well, and very inspiring to follow. Plus, I mean, Andrew, like, he just has a lot of great thoughts. And I think that because most of his thoughts echo my thoughts, and so it's very pleasant to hear them articulated in ways that make me realize that I feel similarly, which is how most of these things go anyway. If ever you hear someone, a philosopher or any sort of orator, like, who makes a compelling argument, and you're like, yeah, that makes so much sense. That's so well said. It's probably because that person just said the things that you have already been thinking about, but had never actually put into words. And that doesn't mean that argument was necessarily compelling, or that you were convinced of something that you think one thing and now you think this thing. But instead it's just like, oh yeah, you're saying the things that I'm already thinking, but now you're just sort of putting it into words. This is sort of like that.
Task is rename a variable, okay? And if I use a tool to rename a variable, and I know that tool will work, I can then do that, make a commit, and never look at the commit. I don't need to review that. I know exactly what that did. I have 100% confidence that it's correct. If I ask the AI tool, rename the variable, I still have to review the code. That's worse. That will take so much longer than the other change, you know?
You are the BDFL, Benevolent Dictator for Life. Can you explain what it is?
Yeah, it's funny. Every time I jaywalk in front of a bus, I think about this. In software projects, you kind of have to choose between having a hierarchical control or having some kind of democratic process. A lot of projects choose hierarchical control because it's simpler. So you don't have people struggling for power, or you don't have to try to build consensus on changes through some kind of voting system. As we know, democracy is difficult. And so a lot of projects will choose BDFL style for simplicity, if nothing else. And that is the default style that a project has when only one person is the maintainer. So unless you try to introduce a more democratic process into a project, then BDFL is what you will get by default.
Why is one dictator better for language design than the committee, like in C++?
The trade-off here is if you have one person in control, then that person has the responsibility to try to understand everything and have a coherent vision for the project. When you have a committee, sometimes you can have the problem where many different people have disagreeing visions for the project. And these disagreements are valid. This person has a valid use case, this person has a valid use case. But there is not a single way to do the project that will support both of these use cases. They're at odds. And so if you compromise, then you end up with a worse product than if one of those persons lost and one of those persons won. And with a committee or with a more democratic process, we try to find these compromises more because we try to cooperate. You know, we want to be nice to each other. We want to help each other. That is what the process leads to is compromise. And while I think that that has social benefits, it also has the trade-off of lacking the coherent vision for the software project.
Don't you feel this model has a risk? Zig today is you. What happens if you leave tomorrow?
Software engineering-wise, I think we'll be fine because my colleagues are very talented and they're very capable of carrying on the operation. However, from a political perspective, from a organizational perspective of the Zig Software Foundation, I think that my work is not yet done. Because if I were not doing BDFL style, then the project would suffer from, if you will, oxidation from being in contact with money. You know, whenever money flows through a system, the system becomes corrupted. And having a strong hierarchical leadership, as long as the person in charge wants to resist those influences, then that will happen. But when you try to set up a democratic process, the money corrupts it. But I don't think that a strong leader controlling everything is sustainable. At some point, I want to retire. At some point, I want to do something else. And you know, we've all seen European history where monarchies are fine under a good leader, but then their offspring is a bad leader, and then everything goes to shit. And so it's not sustainable. You need a democracy for long-term sustainability. And then the challenge is setting that up so that it does not get corrupted over time with the influence of money.
You've been working on Zig like for over 10 years. Like, what motivates you to keep going?
I love my job. I wake up every day excited to work on Zig. To me, it's almost, it's kind of dorky, but Zig project is kind of a shrine to computers. You know, I love them. I love computers, and I want computers to serve people. Zig is my optimistic gift to the world that a great programming language and tool chain will lead to this outcome. And I'm putting my faith in my fellow humanity to use this tool to do this task. I love it. I think that it's like very satisfying to please users and to make software that creates this compelling user experience. It's like a performance, you know. The same thing the same feeling a musician will get from performing on stage, I will get for making great software for users.
What is the hardest part of this process?
Taxes. Mostly kidding, but the paperwork of running the nonprofit. Yeah, and yeah, running the nonprofit is completely necessary to to be legally above board and to accept larger donations, and like obviously this must be done. Someone has to do it, and right now that someone is me. And it's just, nobody likes paperwork. Some days I hold my nose and do the accounting work, and some days I get to do programming, and those are the good days.
And when it comes to actually coding, are there hard parts there?
Sometimes it takes a long time to update code when making changes. So for example, earlier we talked about I/O reader, I/O writer changes that came out in 0.15. Initially, working on these interfaces was very satisfying because I solved a problem. I found an optimum, I came up with an API, I tested it, I got it working, I found a novel solution to the problem space compared to other programming languages. Great. Then I spent the next 6 months fixing the standard library and projects in the ecosystem and updating the code to rewriting code that was working before, now to use these new interfaces. In other words, like taking on the same suffering that I was inflicting upon my users, I also had to suffer in the standard library and that sort of thing. And that was a slog. That took a long time, and some days I had to rally the willpower to continue. But I got through it, and so we got to where we are today. But sometimes these big changes, they do require they do require willpower and determination to get them finished. Yeah.
Have you ever experienced a burnout as a programmer or as a leader?
I think that burnout happens when you're putting in a lot of efforts, but you're not seeing a lot of rewards for this effort. And I think that I'm largely protected from burnout because while I am putting in a large amount of efforts, I am seeing rewards. I do see happy users. I do get to make a release of Zig and look at all the release notes that I just wrote up and see all the improvements that we made. Sometimes the reward is delayed, like when I was doing this big change to I/O and it took many months to update the code. That starts to feel a little bit like burnout because the reward does not come for many months. But eventually it comes and I feel better, So to a large degree, I think that I have not experienced burnout because I do derive a large amount of satisfaction from my job.
Do you have any advice to those who struggle with that? Maybe if you mentor something, is it a topic to discuss with them?
Okay, so the first thing I would say would be don't forget to exercise and get good sleep, and eat healthy. These things compound. So just check those boxes and maybe that will solve the problem. Okay, but now let's move on in the flowchart. I think that a lot of people's jobs are unsatisfying. If you don't like what you have to do, if you think that what your company is doing is not valuable for the world, and then you have to work hard, that's a recipe for burnout. And so you have two choices in that situation. You can do the hard work of finding a different job or trying to do entrepreneurship, create your own job, which will be a lot of work. Or you can slack off and stop trying at the company that you work at. We don't want to believe that that's a good solution to the problem. I think if you have the motivation and energy and drive, the first one is better. But I mean, if you work for a soulless corporation, then stop trying. Go home at 5 p.m. and do something else. Don't try so hard. That would be my advice for people who feel burnt out.
What brings you joy outside of programming?
When I finally quit working as an employee for my career, but at the time it was for OkCupid, I went from moonlighting Zig, working on nights and weekends, which was very stressful, to now it's my main job and now I have this free time. That was a really beautiful turning point in my life because I got to have hobbies again. So the first thing I did after that was run a marathon. I've done one exactly in my life. I think that's enough for me.
Is it possible to quit doing marathons?
I still run. I have to agree with you. Yeah, I think I will try to run another one because I did finish, but I walked the part of it at the end, and I feel like I want to run the whole way. So maybe I will try another one. I also remember, I got to mile 21. I hit that wall really hard and started walking, and then a man ran past me. Must have been 70 years old, and I thought to myself, how? How are you doing this right now? How am I? And even when I saw this man pass me, I couldn't run. I still walked. I still think about that to this day.
That's a lot of motivation, I believe.
Yes, so maybe I'll try again.
It's interesting that he says this because I imagine that there are a lot of software engineers who are going to end up watching, this interview and Andrew in general, and just be like, oh, how are you doing all of this? Starting a new language and the software foundation and redefining the way that cross compilation happens and blah 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 blah. There's so much that you're doing and you're making it look so easy, just like that 70-year-old who was still running on the 21st mile. And I think that Andrew here is not identifying that, or he hasn't done it yet anyway. I get the feeling he's not going to call this out, which is why I'm calling it out. Many of us in our lives have some areas where we are that 70-year-old, you know, and clearly in terms of the success of his career and prowess with software engineering and programming language design, Andrew is, you know, so successful and skilled. And many of us are on our 21st mile and we're just like, oh man, I just can't even do this anymore. How did you ever do this? But there are plenty of other things in our lives where we just don't have that. And we probably never will. And that's okay.
Marathon.
I also read somewhere that you're learning Japanese, right?
Yes.
Why?
そうだね. It's hard. It's very hard to learn Japanese. And I'm United States born and raised, so I only know English. And I always wanted to know a different language just to be, you know, part of the world. And so I picked Japanese. I've always loved animation. I like the challenge of learning Japanese, and I think the culture is like very interesting. And I have to say, shout outs to my my tutor, Yuko. She's a very, very nice teacher who I found recently in Portland, Oregon. Because it's so difficult to learn Japanese, I've sometimes suffered from a little burnout trying to learn. But after I found Yuko sensei, my motivation has picked up, and I feel like motivated to keep studying every day. So I wanted to say thank you to her.
How many hours per day?
Maybe one every day.
What does success look like for Zig?
I think there's two answers to this. So in one sense, you could say it's already been achieved because we have a diverse income stream. So we have financial independence from any single entity. We already have users who are happy and who continue to use Zig. We're already working on improving it. Every year we have about 2 releases. And so this is nice. This is sustainable. Like, we don't have to change course. The course is good already. From one sense, that's already done. From another sense, I do think that I would like to see more adoption. One measurement of success would be adoption on the level of Go and Rust.
When you say adoption, is it important for you to have?
I like Andrew's perspective on goals here, and maintaining reasonable goals. I mean, still like impressive, but not just entirely unreasonable goals. Like, and just being satisfied with enough. So one of the things was when they were talking about his salary, right? He said, like, I make enough to feel upper middle class. I can buy groceries comfortably. I can pay my mortgage in Portland, Oregon comfortably. And the rest of the money can go toward paying contractors. And he said, like, I think the quote was, "I'm comfy, I don't need more." I think that it seems like he has a similar sort of mentality for Zig's growth as well, where it's like, okay, well, yeah, we have multiple corporations, sometimes really big ones like Uber, that are using Zig and are happy with it. We have a software foundation with diverse income stream, and he's able to work on this full time with five other full-time contractors, and build the language he wants to build. Like, it's kind of like, how much more do you need? You know, at that point, you kind of hit success. And the problem is that many of us are on this sort of psychological wheel where it's like, oh, if only I get that promotion, and then you get the promotion, and it's like, okay, well, if only I get that new car, and then you get the new cars. Well, I just need a bigger house, and then you get the bigger house. Then it's like, oh, well, promotion season's coming up again. If I want to get promoted again, and then it's just nonstop, right? It's like you're never satisfied with what you have. And I like Andrew's more stoic philosophy. Yeah, he hasn't spoken so much about personal philosophy, but it shines through in the way that he talks about everything else. That also aligns with the way that I try to live as well. Which, like, you don't quit your job to focus on building a programming language if money is a huge concern. You know, like you get to a point where it's like, yeah, I worked in tech for I don't know, 13 years or whatever before I quit my job. I've made enough money. You know, like sure, I can make a lot more. Plenty of people who are working at Google and Netflix and whatnot are making a lot more money than me. But I make enough to be able to cover my bills and then focus on the stuff that I want. And I would hope, like, I find his philosophy there inspiring as well. Because when it comes to measuring, like, what does success mean for Cenk doesn't need to become the next C++. Like, I wouldn't expect that to be the case. It's unreasonable, really. If it does, wow, that's amazing, but probably won't. But if it can become the next Zig, you know, or like as successful as Zig, to the point where there's a foundation that you can get like reasonable salary from and work with people with similar goals on something that you absolutely love building. Like, I mean, that's kind of the dream, man. That's kind of the dream. I feel like what the old guy in the marathon did right, that is easy to say but hard to do, is pacing. Yeah, that's a good point, DJ Blue. The guy just feels like an inspiration every way. Nice. Glad you like it, Johnny.
Of commercial adoption, or it doesn't matter?
Commercial adoption is useful because we can get money from corporate donations. We have to be careful to keep those diverse, but it's still very useful. So I would not ignore this use case. And also, to make something that's generally useful, it will certainly be useful for corporations. And we can see this reflected in how many companies or how many people are using Zig for AI right now. You know, if you make something useful, people will use it. So that's good. You know, even if I find someone's vibe-coded project personally to be boring, I do think that it would be a sign of a useful programming language that people are doing what's popular with it today.
If you could go back to 2015, would you still start Zig?
Absolutely. The day that I quit OkCupid and started to work on Zig full-time was the best day of my life as far as the trajectory of where it went. I'm so happy that I did it, and it's just given me a profound sense of fulfillment and independence and just like a value of myself, of how I see myself and contributions to society. I think that I'm basically unemployable, and I got lucky through my career that no one found out. And I needed to be my own boss in order to be happy. And so once I was able to do that, then I achieved happiness. Now I am happy.
All right. Yeah, that was pretty great. You know, he said, one of the things he just said was the day he quit OkCupid to focus on Cenk was like happiest day of his life. I think he said something. Where was that? Yeah. So this is a comment from him on my blog post. So this is on the Lobsters website. And I put out a blog post when I quit my job, to focus on Jenk. So the job's like, I quit my job to work on my programming language. This was January of last year, right? And so he had a comment here. It said, "Congrats, welcome to the club. I suspect this day will mark 2 halves of your life," which is dramatic, but also like coming from someone who's actually done this, years before. It's also kind of like, if someone's gonna know how it's gonna feel, then it's gonna be him. So yeah, I'm looking forward to following that path, and yeah, he's quite inspiring. All right. So, with that out of the way, let's do some coding. We want to do a bin watch, bin compile. We want to do a 16 on that. Oh, let's configure. I think we probably want to do something like a debug build. So where we're at now I did not want that one. Where we're at now in terms of optimization is that we have successfully optimized Jenk to have the execution time for the ray tracer be faster than Clojure. So we're not going to worry. We're not going to work on any sort of optimization work today, because in terms of optimizing the ray tracer, I've already hit my target, which is Jenk is faster than Clojure. So I think where we ended with, which is like 2.36 seconds here, and then Clojure best I got was 2.52. So we're marginally faster. I wasn't able to get like something close to 2x or something. When I look at the flame graph for what's there, it's just it's just hard to remove anything else that's there. Everything that's there just kind of feels like it has to be there. So I think that there's probably more that can be done, but at this point we're faster than Clojure, and that was my main goal. So the main thing that we want to get out of this is, I probably want to do a bin clean, and then we'll build. So we added a couple of optimization passes to the IR. And one of the things I want to do is I want to hook those into compiler flags. But the way that I want it to work is going to require a redesign of the way that we handle compiler flags. And I think I'll do that. Yeah, I think I'll do that. So I have in mind a design for how I want compiler flag handling to work. And I'm gonna show you what I have, and I'm gonna talk about why I want it to work in this particular way, and the UX that I have in mind, and how we're gonna be able to achieve that. So one of the biggest complaints that I have when it comes to C++ compiler flags is when you enable something like, and C++ compiler flags, of course, there is no like single C++ compiler, right? You have so many different C++ compilers, and I'm talking about all of them. So I do mean generally the flags that we pass to compilers, in particular, the flags that we pass to Clang and GCC. Johnny, eliminating keyword calling inline overloaded invoke method using This one. So actually, no, Johnny. The that one was I did try that optimization, which was after adding an keyword overload to get. I ended up. So this was something that got me. There are two different numbers here. There's the smaller millisecond number, and then there's the larger second number. I started with the milliseconds, which was a smaller benchmark, and then the larger number is what I'm going to be using for the post. So I was able to get my fastest time by adding an overload for keywords, but I ended up not keeping this because it'll help with this benchmark, but it's not going to help with other benchmarks. In fact, it's going to slow Jank down for other use cases. Because only array maps can actually benefit from having the keyword type information. But if you look up in a hash map, then having that keyword type information is not going to help because you just need to get the hash of it anyway. And also it just it burdens the whole object API by adding yet another virtual function in. And so we can trim off another, I don't know what this is, 3% or something like that. But it's just not it's not worth it enough. And that's going to be a point in the blog post as well, is that it's not that I'm just doing everything that I can to make Jank beat Clojure in the benchmark. It's that I'm only doing things that actually make sense for the API that we're building as well. I want this code to make sense. The eliminating keyword calling is a optimization that is done during analysis, so that we detect if we're in a Clojure file. So I'll show you. So if we take a look at something like this, right? So when we have a map, so we're scaling a vector here. The vector is called L, and vector here, vec3, is a map of RGB. And we're scaling this by n. And so when we call the keyword here in order to grab R out of L, this is the thing that we want to optimize. And so keywords themselves have a invoke function. And this optimization that I did here was to not invoke that, but instead to have the compiler inline this to just directly call the C++ get function instead. I don't know exactly what it maps to in Clojure JVM, but yeah, that sounds right. Yep. Okay, what was I saying? I forgot. Oh, right. One of the things I don't like about C++ compiler flags for Clang and GCC is that when you specify like 01, 02, 03, you really have no idea what optimizations that enables. Let's take a look, for example, if we do Clang CLI reference. And so let's take a look at 03. Okay, so optimization level, flags controlling how much optimization to be performed. We have dash big O and then some number. And then, O fast is deprecated. That's it. It's okay, so what optimizations are enabled when I do 01? What optimizations are enabled when I do 02? What optimizations are enabled when I do 03? Can I hand select which of those optimizations? What if I want what if I want 02, but I want this other optimization that is part of 03 as well? I don't like that, all of that stuff isn't listed. Now, maybe they show up somewhere else, but I don't actually think that they do. And so for Jank, What I want is to be able to say, okay, so O1 is just a set of, it's just shorthand for a set of flags. And so we're going to have a flag for every single optimization that you can enable in the Jank compiler. And when you say O1, all you're saying is, I just want the set of those to be enabled. And when you say O2, you're saying, I want the set that's in O2 to be enabled. And you're saying O3, I want the set that's in O3 to be enabled. And that way you can intentionally enable entire sets. You can also intentionally enable specific optimizations. And then you can also intentionally disable specific optimizations. And so that way you can say, okay, well, I want O3, but I don't want var deref hoisting. And so you would say you would say O3 and then O no bar deref hoist or whatever we're going to end up calling that. That we'd probably put the verb first. So no hoist var derefs, something like this. And so this would enable everything in 3, but not include this. Now, the way that I want it to work as well is, do we want ordering to matter here? So should this arrive at the same thing? Not disjoin O3 hoist var derefs? I don't know what you mean, fromophobic. Data rather than strings. Well, we're talking about command line flags here. So I think that Johnny, you and Fromophobic are both kind of thinking along the same lines, which is like, well, why don't we just have a declarative way to say this? But that's separate. So we already have the whole line jank plugin, which works with line again projects and accepts declarative flags. And so you'll be able to specify your optimization flags inside of your project there. And then that'll just be data. But that won't be like a function of data. It will just be a data representation of the flags you want to pass, which would be something like, we're not in a closure file, but will be something like optimizations, maybe like, I don't know, level 3, and then no hoist var derefs. Or like enable, disable, something like this. So this hasn't yet been designed, but this would be part of the project CLJ, and then this will just be turned into the command line flags. But I don't want the compiler to be reading from Eden files. No, the compiler should just deal with flags, and then the additional tooling is what should be working with the closure data. But now we have the question of, does the ordering matter? The way that C++ compiler works for Clang and C++, I'm sorry, Clang and GCC, is if you do something like 03, 02, then the latter one is just going to replace any of the former ones. So in this case, it's not stateful. Is there a Clang C++ function that is somewhat analogous to Clang compile CLI? So you mean, is there a function that's part of the Clang C++ API that is analogous to invoking Clang from the command line? That's what you mean, Franmophobic? If so, yes, kind of. There's this thing called the Clang driver. So we have this utility in clang.cpp. Lots of stuff about finding Clang and finding Clang's resource dir and everything. So we have this invoke Clang function in Jank that ends up creating a Clang driver. So you have a driver right here, which is a Clang driver, and then you create that with some args and a target triple, and then you have like some shit to handle your diagnostics, and we put in some extra flags, and then you build a compilation, which gives you a compilation result, and then you can execute the compilation. So it's not quite the same, but this is as close as Clang gets. But we don't use that here anyway. So that's unrelated to what we're doing here with these flags. These flags are entirely for Jank. I'm just using Clang. I'm just using Clang's flags here as an example of what I don't like. But I'm also using them as an example of what C++ people will have a mental model for, because I don't want something that's entirely new and foreign, but I also don't want something that sucks in all of the same ways that it has sucked for the last couple decades, right? So yeah, I was saying that the way that Clang works is that if you pass 03 and then you pass 02 on the same line, so you'll just do like Clang CVV like this. 02 is just going to replace 03. So it's not stateful in the sense that like, okay, let's enable all of 03 and then now let's enable all of 02, which basically does nothing because we've already enabled 03, and then compile main.cpp. Instead, it's just take the last one. Okay, we have 02 enabled. Now for ours, I think it might make... I don't know if I want it to be stateful or not. The benefit of it being stateful is the order doesn't matter. As much. Order will still matter, but it won't matter as much. So in this case, if you were to do this line versus if you were to do this line, both of these would just work. But the problem is if it's stateful and you do something like this, where you end up doing 2, then like once you've already enabled 3, you can't just switch to 2, which means you're not able to, like the way that Clang and GCC work is basically the last flag wins. And so they just, each optimization flag ends up overriding the previous one. And that's a very handy feature. I will say in build systems, it is very handy to be able to just tack a flag on to the end and know that it's going to override whatever came before it. Ordering would be very annoying when mixing CLI and jank flags. So what do you mean by that, Kyle? Like, what are you proposing here? That we follow what Clang does, or that we do something stateful or something else? I think that this stateful like situation right here will get us into trouble. I think that this is going to be a real pain in the ass. Follow Clang. I hear you. Now tell me this then. And also I'm glad that you're here because we don't have many C++ devs in the community. So let's say that hoist is such a tough word to say. Let's say that hoist var derefs is part of O3, okay? And so let's say I enable that, and then I also add O2. Should O2 overwrite? No, because O2 should only step over O3 or O1 or O0. And so these have to be separate. And so this, these two will be the same. These two will be the same. Also, sorry for the black screen right now, but I gotta click away for a sec. And we're back. ON should only be additive. Mm-hmm. Yes. Okay. Yep. Okay. So I think we have an idea now for how this should look. Now, what I want to do is from Jank's documentation, I want to be able to say like, okay, O1 is just a set of these flags. And sure, that'll change, you know, as we add more optimization passes, and that documentation will need to be updated. That's how user documentation works. And then it'll be the same for O2 and O3. To me, that's just going to be so much more user friendly than how Clang and GCC do it. And it's going to allow you to like have a, you know, really fine-grained control to say like, okay, well, what does O2 even mean? You know, like, what am I not doing when I do O2? And you can answer that by just taking a look at what O3 is, you know, and the optimizations that are in there. And so if you're like, okay, well, yeah, I want O2, but I want this other specific thing like hoisting bar derefs, then you can do that. That's going to work. Okay, so this is our goal. And optimization flags should, so, okay. Now, with that said, Jenk used to have a library that we used for handling all of our command line arcs, because I was like, oh, why would you implement this yourself? So we used a library called CLI 11. And then I ran into so many issues where I just wanted to like have a command that like this flag only applies to this command, or this command has subcommands, or like this is a global flag that I want to be able to apply anywhere. Or I don't want the ordering of this to matter. I want to be able to specify the flag before the command or after the command, even if that flag is specific to that command. And I was just not able to like do those things. I was not able to achieve the UX that I wanted using that library. And so rather than just trying my luck with another library, I just wrote my own command line parsing, and it's a few hundred lines, but it's not general. It's a few hundred lines of like specifically handling every flag that we care about, and the parameters that they accept and everything like that. I think it's so much saner. It's so much saner. And then the other thing is that libraries tend to like, you encode the documentation string as part of some object for the command, and then flags for that command, you know, they have their own documentation strings, and then it puts everything together for you to generate your help page for you. But then you don't get control over the formatting of how that help page looks. And so if you don't like the way that things are being vertically aligned, or like how defaults are being rendered or whatever, then you're out of luck. So instead, I just have a fucking string. I just have a fucking string. And then when I add a new command, I just add it to here. And what do you know? It just works. Okay, so the main thing that I want to do here is I think we could do this. We could just focus on optimization levels for now. And what we're going to end up with is, for all of the different optimization flags we're going to have, we're going to need a value that specifies whether or not that flag has been passed. And so let's do something like CLI. I'm going to do something like this. Right here, I'm going to do a struct, and I'm going to call this options scratchpad until I come up with a better name, because the actual CLI options are here. But the thing is that the scratchpad, is, I need to know additional things, like, has this value been passed? And So I want to use something like a JTL option for that, but I don't want to change the public interface for this options value to have an actual JTL option for U8 on here, because the whole thing is like, I always want, when I'm consuming this runtime optimization level in the rest of Jenks code, I always want there to be a value there. So it doesn't make sense for this to be a JTL option, because none, which is the value of an option that isn't present, is not acceptable within the domain. I always want this to have a valid value. But I need to be able to convey that somewhere. And so that's why I'm going to have this hidden struct. And so we're going to use this hidden struct in order to then later construct our full like public facing struct. And that is going to give us what we need. So basically, the lesson here is about not exposing implementation details into your public API, pretty much. So let's just hook this in before we add any new flags. Let me see where I'm handling this. Okay, so we have -O and optimization. And then we just change, we have this ops, which is a global, and we just change that directly. And so I don't want to do that. Instead, I want to create a scratch pad. So options scratch pad, we'll call that scratch. And then that will default initialize itself. And so then when we get to here, I want to say scratch like that. And then why is this? That's annoying. But I don't know if there's anything I care to do about that. I don't know if that's actually going to prevent compilation or not. It is. So it's because this value is a U8. And it's a U8 only because you don't need more. But we're taking an int here, which is 0. I would love to have a suffix for this. Maybe we should add those. I know that C++ requires that you use underscore for user-defined suffixes, and that looks really ugly, and so I tend not to do them. But yeah, for now, I think we're just gonna have to do a really ugly cast. It's either a really ugly cast or it's changed the type. And neither is very compelling. Okay, so now we have this scratch. And then do we set codegen? Okay, that's codegen optimization. Do we set this? scratch. Okay, and then right at the end of everything, the last thing we're gonna do is we are going to construct so right now we're still filling in a lot of the global options as we go, but what we're gonna do going forward is like everything here is gonna end up being duplicated into the Scratch first, the Scratch struct, and we're gonna populate that, and then only once we make it to the very end are we going to initialize this guy with the Scratch, and then that's going to commit. So let's do a static void commit Scratch pad that takes options, Scratch pad, Scratch. Okay. There we go. And now we'll say options dot runtime. So here's where we get to choose our defaults as well. So we'll do an unwrap or 0. And then CodeGen, this is Scratch. What's this called? Oh, it's called ops. Okay. So now the things like the defaults here, for example, that won't matter. This is actually still the same thing because it's just going to 0 initialize it. But I want to be even more explicit that we're not worrying about that. We're just kind of being good C++ citizens by making sure that at least things are default initialized. But yeah, like this isn't going to matter because we're always just going to end up. And later on, like I guess what we'll do here is we should just do this. Later on, what I want to do is we'll actually just construct a whole new, like commit scratchpad is probably just going to use a constructor for options that takes in the Scratch or something like that. And so we're just going to construct everything. Yeah. Like maybe there shouldn't even be a default constructor, and then we don't need to worry about default initializing all of these things because the only way to construct an options is through a Scratch. Yeah, I like that. Okay, so here's our O flag. And then what this is doing right now is it's still just setting this CodeGen optimization level. So the problem is that we still are using a C++ compiler behind the scenes, which means we still need to pass like 01, 02, 03 to Clang. And it's going to use that when it compiles our C++ code. But the number is also going to be used in order to select which optimizations are going to be enabled on the Jenk side. And so that means that we need to, this is this CodeGen optimization level. We need to sort of pass that onward. But we also need to break out the different the different optimizations that are part of that on the Jank side. So let's take a look at the two passes that we wrote. So we have, actually, I guess we have three here: remove nops, hoist var derefs, and hoist literals. So I think that hoist literals and remove nops should be in O1, because as long as we're doing any sort of hoisting, we're going to want remove nops, because hoisting is just going to result in there being some nops for anything that was alighted. And then hoist var derefs, I think we can put in O3, because that has not semantic breaking behavior, but semantic bending behavior. And that should be reserved for O3. So let's put these two into O1, and let's call them, like, let's add a flag for both of these. So also, do I document the, no, I don't. This is going to be a good time to document so this is the level of optimization used by the JIT runtime. And this is the level of optimization used by used during code generation in general. Well, for both AOT and JIT compiled code. So this warrants more explanation. This one does too, honestly. Okay, and then for this one, this is the level of optimization used during code generation. Okay, so yeah, this is a little, like, it's a little, I don't want to say convoluted, but it's a little complex and nuanced, and I'm trying to describe that here. So yeah, we have two different optimization levels. One is, one applies to the JIT runtime and Clang, and so if you're trying to like do a Jank run or a Jank REPL with some benchmarking in there or something like that, then it makes sense to specify this optimization level. However, if you're doing just AOT compilation, then only the code gen optimization level makes sense, because like how fast Clang is, like how fast the JIT compiled code is during AOT compilation just really shouldn't matter. And this code gen optimization level is going to affect the like actual IR passes. So when we're talking about like hoisting literals and removing NOPs, this is going to be coming from the code gen optimization level. Milky Cottage. So I've used Cache. Should I install Base Arch? If you want. Do you want a lighter weight Arch experience? If so, perhaps using Base Arch will give you that. I'm not on Arch or anything Arch based currently. Appreciate the follow though. Welcome to the stream. Do it with your stream running in the background. Nice. There's it's nothing quite like a fresh Arch install though, Milky Cottage. I do enjoy starting fresh with an Arch install, and setting everything up, going through the Arch wiki for the like early setup instructions, for everything that you need to configure your machine. The problem with that though, and why I don't use Arch any longer, is that feels really great, and you have all, like, you know the packages that you have installed and you know why they're installed, for like a year. And then once you've been using the machine for a while, and you've installed a bunch of stuff sort of one-off because you needed it for that time, whatever, then you're no longer at a point where you're just like, yeah, I feel like this is the slimmest machine it needs to be. And instead it's just like, I have no idea why I have these things installed. I have no idea the things I have installed that I don't even know about. They're like, and like, I don't even know if I can remove these things because, all these things like optionally depend on it, and I don't know when I last used it, and blah, blah, blah. So that's why I just use NixOS, because then I can declaratively say, like, I have a set of Nix files that just describe the machine that I want, and then I just tell NixOS, yeah, go build this machine for me. And so if there's something that I actually want persistent in the machine, like a package install or something like that, I have to write it into a file. And then the thing about writing it into a text file is, like, the way that my mind works is I will put a comment next to it. I'll put it in a group of development tools, or I'll say, like, oh, I need this because this other thing. And so when I come back to it in the future, I'll know exactly why it's there. And also I'll know that I don't have anything installed unless it's in those files, because that's just the way that Nix works. And if I want to install something temporarily, then I'll just do a Nix shell. So it's like, oh, okay, I want to like quickly download some YouTube videos. So I'll just, like, I don't have YTDOP installed on my machine globally. Instead, whenever I want to use it, I just enter a Nix shell for YTDOP. It'll download it if necessary to get the latest version. In this case, there wasn't a need, and so now I have it. And then when I'm in this Nix shell, when I exit this Nix shell and I run which, it's like, oh, nope, nothing there. Sorry, it's not found. And so a lot, like all the one-off stuff that I want to use, I just quickly get a Nix shell that has that, use it, get out of the Nix shell, and then I don't worry about it. Isn't Arch Linux kind of the C of programming languages? And NixOS is like the assembly? I don't know. Maybe Arch Linux is the C. If Arch Linux is the C of Linux, then NixOS is probably like the Haskell. Kyle says NixOS is the closure. Kyle knows Nix better than I do. So I would take his word for it. Okay, so I'm writing these. Okay, so hoist literals, done. Remove nops, done. And then we have an option bool. Yeah. Yeah. Okay. So this is 01. And we have 02, and then we have 03. And so inside of 03, we're going to have hoist var derefs. Var derefs. Okay. So what we're going to do now is what I want to do is an ops code gen optimization level. And we'll do a case 0, we'll do a case 1, we'll do a 2, we'll do a 3. Do we need a 0 actually? No, we don't. And this does not have, I'm going to ignore this. That's fine. Okay, so because we know that this value can only be 1, 2, or 3, maybe we should just use an enum for this. And then that gets around the whole casting problem as well. Yeah, we should just use an enum for this. You went back to Windows for a few days? Already tired of dealing with it? Man. I'm sorry that you had to go through all of that. I don't know how much I would need to be paid to use Windows, like to do my development on Windows. But it's a lot of money. I'll know it when I hear it. Yeah. Okay. Just so I don't forget, we're going to do an enum for that. It's going to be cleaner. Then we don't need the casting as well. But for this, what we're going to say is if the code gen is this, then what we want to do is scratch hoist literals. How do we want to convey this? because we ultimately want, like, all of these things here need to end up being bools. Like so. Why do you find Windows so painful? It's like fine using WSL for most things. Can't customize your workflow. Yeah, I mean that's it. Like I completely agree with you. If you look at my setup, like I'm in a tiling window manager. So already I have complete control over like how I interact with my windows, how many desktops I have, where things go, how big they are, and everything's keyboard driven. And already just the usability of that on Windows, you just can't achieve that. I simply cannot achieve this level of control over the usability of the desktop environment. Like, forget everything else about how it is to interact with open source software and build systems and compiler compliance and like general development stuff. Simply just being able to control your desktop environment. It's not feasible. Okay, so if I have these bools, and if we have option 1 enabled, then what I want is I want to say hoist literals is equal to unwrap or true. And so that way, if hoist literals has been explicitly set to false, then we'll use that. Otherwise, we're going to use true because we set our code gen optimization level to 1. So same thing, remove nops, and then hoist literals var derefs, literals var derefs. Okay. Yeah, I think this unwrap or is basically giving us everything that we need here. Now, the only other thing is we need to be able to enable these optimizations manually, enable or disable them. And I probably want, rather than having an entry here for every single one of them, I probably want a loop through some data to just check if the flag is one of those. So if we have like a pointer to a member and then also a string name, then that's going to give us everything that we need. Yeah, I'll do that. All right, I'm going to step away for just a sec. I'm going to fill my water, use the restroom, and I'll be back in a couple of minutes, and then we'll continue implementing this. Hang tight. All right. Oh, you know what? I was enjoying the silence. Da, 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 da. So we need a map of these flags, and we need to loop through and check if those flags are set. So we'll do that right here through optimization flags. Yes and no. And how that's going to look is we're going to have something like a static native unordered map of a JTL immutable string to a pointer to member. Let's see if I can remember the syntax here for pointer to members. So we're going to have a pointer to a option scratch pad. Yeah, is that what I want? think so. And so this will be optimization passes. And then we're just going to initialize this guy in place. So we're going to say hoist literals to, and then this is going to be the address of option scratchpad hoist literals. And this will be hoist var derefs. And this will be remove nops. And this will be const, which is going to make that go away. Nice. So assuming I didn't fuck up my syntax here, what we have, this is a pretty uncommon C++ feature. Nice. Where we have, I'll explain this because it's cool. Like I think it's nifty. It's also a little sad. But this member, this is a pointer to member syntax. And so basically what this is saying is this is a map of string, and JTL immutable string is just Jenks immutable string. It's a map of string to a pointer to a member of this struct specifically, option scratchpad. So it's a pointer to a member of this struct specifically. And the member must have the type JTL option bool, which these guys do. These three do here. So it can be a pointer to any member of option scratchpad as long as that member has the type JTL option bool. And so we can initialize it here with the address of hoist literals, the address of remove nops, or the address of hoist var derefs. Now, the interesting thing here is there's no object here that we're getting the address of. Like, we're not saying, okay, I have an object of option scratchpad and I'm getting the address to this particular member of that object. Instead, what we're getting here is basically an offset. We're saying from some object, which we don't have right now, but from some object, the address of hoist literals is basically the offset from the start of the object to that member. And so that's what that pointer is. It's basically an offset pointer from the start, from the beginning of some object into the member. And so when we invoke this, we're going to need to use a pretty weird syntax because we're going to start with our option scratchpad object, and then we're going to use some arcane syntax that tells C++ like, okay, now offset this object to this particular pointer address, and then grab the value there. And then that's going to allow us to basically have a higher order way of working with these members. Now, in Clojure, or a lot of other higher order, a lot of other functional languages, we would just use like a function. We would just use a function here that takes in an option scratchpad and returns the hoist literals member for it. We could do that in Jank as well. Like, if let's say we did something like this, where we take in. So here instead we have a map of string to this is just a C style pointer to function. So we have a pointer to a function where the function takes in a ref to const option scratchpad and returns in this case actually we would need a ref because we're going to mutate. So we return a reference to the scratchpad, and then or we take in a reference to the scratchpad. We return a reference to the actual member. And then in this case, what we could do is we could say, okay, so we could use auto here, or we could also just option scratchpad. Let's do that. And so here we could return s hoist literals. And so this will give us the same sort of thing. var derefs. And I'm typing all this out so we can compare, because I believe that the one I chose is actually the shorter one. Yeah. So this one, and what's my error here? Doesn't like that. I don't know why it doesn't like that. So this one's pretty similar, except probably would work the more like how normal people would think about this, which is just like, okay, here's a function that takes in this option scratchpad and returns me a reference to the member. Instead, we can just work with the members directly. This particular error, no action constructor for another map, because the types don't end up lining up. But yeah, I don't know why anyway. And I'm not going to worry too much about it, because that's not the type. That's not the approach that I was going to use. So instead, we just use pointers to members. And so what we're going to do is we're going to have a to-do right here. So we're going to loop through all these members. So we're going to say auto const. And so we'll call this pass, because we have passes, optimization passes, we call this. Fromophobic, clearly not smart enough to use C++. You are, brother. You're a smart cookie. Okay, so for this one, we have a pass, and so inside our pass we're going to have first, which is our immutable string, and then we have second, which is our pointer to member. And so what we're going to do is we're going to yoink this if check, and our flag here is going to be formatted. So we're going to say this. And we're going to say pass.first. So that way, if pass.first is equal to hoist var derefs, then our flag ends up being hoist var derefs, like so. So that's what we're building here. Now, if that's the case, now what we've been doing is in all of these checks is like, okay, well, if the flag is set, then blah, 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 like let's just set the value directly. But we're high order here. So all we have when we have our second here is we just have a pointer to that member. And so what we need to do is we need to, I believe, what's our syntax for this? It's something like this. Here, let's see if I remember this. I don't remember the syntax. Let's look it up. You know, I just watched a video of Bjarne Stroustrup, the creator of C++. And there's a short clip, and the title was like, does Bjarne know all of C++? And some interviewer asked him that. And he said, no, like I don't know, like all of C++, you shouldn't want to learn all of C++. Like instead, you should use websites like CPP reference and be able to look up what you need to look up when you need it. And so he quoted some English philosopher. He said, like, there are two types of knowledge. There's knowing something, and then there's knowing where to find something that that you don't know, but that you know that you can know if you just go there to find it. And so it's like, you know the name of something, you know what you need to search, and that will get you where you're going. Let's see. Okay, pointer to member. Pointer to member. There's our pointer to member, but we wanna access this. So it is the .star. This is for functions. What about for that's pointer to member functions. This is a pointer to data member. Here's what I want. Yeah. Okay, so we do just do this. I was right. But what's the problem here? Yes, true. Oh, okay. Never mind. Had it. Okay, so the other thing that we want to check for is no, the no version. And so this search allows us to automatically support, and I'll write this out here. We automatically support flags like oh foo and oh no foo here. And so that way you can explicitly turn off an optimization if you want as well. And oh, we were in the middle of an else if chain. So maybe we should actually put this somewhere else. Else if else. Okay, so I guess when we get into this else, we could do this here. But the problem is we would need to know if this is handled. So we're going to break and we're going to say handled is true. And then if not handled, then it's pending. Okay. Cool. So yeah, so this syntax here, we start with an invoking object, then we use this .star, and this is basically .star is like dot is I want to access a member. Star is I want to deref something, like a pointer, and so it's like I want to access a member, but I need to deref a pointer in order to get to the member. Is how you think of .star, and so the thing that you're dereferencing is the member that you want to access, and that is this pointer to the member right here. So you dereference that, and then you use the dot in order to access it, and there you go. Bob's your uncle. Cool. So now that should work. That should simply work. But we don't have a good way to verify this. So let's just put a breakpoint in. Let's just put a breakpoint in commit scratchpad. So we'll do a jank run test.jank. I don't know what's in test.jank right now, so let's take a look. And just some stuff. So we'll do that. Let me just make sure I can run this. We do have a working build, debug build. Very slow debug build. Not to worry. Okay, so now what we'll do is we'll say if ops hoist literals. So we're not actually checking for the optimization level here, because the level actually just enables the like bunch of individual flags, right? And so instead we're just checking for the specific optimizations that we want to do. And so we'll say, okay, now if we're hoisting Vardy refs, then do that. And then similarly, if we are removing nops, then do that. And we're going to check these for every single function, but I'm not too concerned about this because this is not a hot loop anyway, and the branch predictor is gonna guess right after the first loop on this anyway. And if it becomes an issue, then it'll show up in the profiler. So not concerned about just checking all these here without moving them out into a const or something like that. So we'll save this. That will auto format. And yes. So then we were just going to try this with a debug. So let's do something like, so when we do O3, we're going to have, let's just do O3 and verify that we end up getting these optimizations enabled. And we'll just verify that with the debugger. So I want to break on commit scratchpad. I'm just going to yoink that right here, and then I'm going to paste that. Cool. So let's take a look at scratch. So we have a runtime optimization level, which is 0. Where's this 1? How am I to interpret this? This \0 is a null. I don't know. I don't know how I'm supposed to read that. Because these are all strings, but they're optional bools. Yeah, that's why these don't render. Oh, but the other ones were optional. Oh, the other ones were optional U8s. Yeah, not very helpful. But if we take a look at this, so we'll do ops, runtime optimization level. Yeah, so we want an enum here, but this is 1. And ops code gen optimization level, that's 3, good. And so, okay, so here's our first bug. If 3 is enabled, we want to do all of these things. So we actually want to put these in reverse order and then fall through. And so we're going to use a annotation here to say that we're going to fall through. It was only allowed on empty statements. What's the fix available? Oh, do I need a... Oh, I see. Okay, so this way, if 3 is enabled, then we're going to do this, and then we're going to fall through to 2, and then we're going to fall through to 1. If 2 is enabled, then we're not going to do 3. We're going to do 2. We're going to fall through into 1. If 1 is enabled, then we're going to do this. Hey, good night, Johnny. Have a good one. It's like 2:40 a.m. Oh man, get to bed. Thanks for hanging out. All right, break and step. Okay, so we have our code gen optimization level is 3. We're going to step into here, and so ops hoist var derefs is now true, and then ops hoist literals is true, and ops remove nops is true. Cool. So now if we were to do something like this, no hoist var derefs. So I want 3, but I actually don't want the only thing that's whoops. Oh, great. So this is already helping us out because we need to check. We need to check this before, because the matching of the -o right here is catching the loop that we have, or is catching the flag that we have before we get to our loop. So we'll just do that. Let me grab this. So we're going to put it first. I think we're still going to want to keep track of whether or not we're handled. Yeah, because so Rust has this great feature that when you're inside of nested loops, you can break from a label. And so you're able to like break from the outer loop as well. C++ doesn't have that. So we'll have to say if handled, then continue. And then we can remove this from here. All right. Let's try that. Okay. Problem goes away. And then we have long ass waiting for LLVM times. Nice. So let's set our breakpoint and then try this again. Now, why was that? Ops code gen is 0. So this is being handled, this is being considered as handled, but it's not right. Let's try this again. That's not helpful. Moving on. Okay, so here's hoist var derefs, and we don't match either of those. Okay. And then here's remove nops. And then there's a third one, and then if handled. Because what is our might be helpful to, okay, so this is on run right now. Let's put a breakpoint at the top of the loop, 234. And then, okay, so now we're on no hoist var derefs. So we get into here, handle this false. This is hoist var derefs. So we shouldn't match this, but we should match this. Yes, we end up setting this guy to false. We break, handled is true, we continue. I think we didn't increment the iterator. Is that the problem? Nope, iterator is incremented here. What do we do at the end of this loop normally? Nothing. We just put things into the pending flags. Does check flag end up incrementing? Yes, it does. I see. But we use check flag here. Let's see what happens. We continue. We're here. It is now test.jank. So we ended up passing false. It's this problem. It's this true that should be a false. I believe that, yeah. Okay, that bool at the end says that the flag needs a value, and then we end up pulling out the value and incrementing the iterator, but these guys don't need values. And so when we were invoking jank, we were saying jank run no hoist var derefs, and then O3, and then test.jank. And so when we ran into no hoist var derefs and this was true, we were then consuming O3 as the value for this flag. So that was just a silly bug. Silly bug. Okay. So code gen optimization level is 3, good. And then we should have false already in the scratch for hoist var derefs here. So now when we take a look at hoist var derefs, it is false. So even though we have O3 enabled, we have disabled that flag. Perfect. So this works exactly as it should be. Exactly as it should. And now we have a mechanism to add however many flags, however many optimization passes we want. We just need to add them to the struct, add them to the map, put them in the correct level that they are initialized, or they should be grouped in, if they should be grouped in into anything. And then when we commit, no, this is already in commit. That's it. Just those 3. Nice. So now we just need to add the docs for this. I wonder if we want a whole section for optimizations. I don't know if this should necessarily go in the help output. I want help to be helpful and not necessarily exhaustive. So I'm thinking that this is the sort of thing that goes in the jank book, which is like a reference, but is not the sort of thing that prints out to the terminal. Yeah, I think so. So in that case, we're done. That's it. And now we have our mechanism for having the scratch pad that we can then commit to our public facing options. We have these 3. Yeah, direct calls right now are not considered as a optimization flag. They should be. But they're not going to be enabled by any specific, it's not a pass. So maybe this isn't. Yeah, maybe this is like other optimization flags. And then we have a direct call right now. Direct call should honestly, it should just be handled by the same mechanism. So let's do optimization passes, and then we have another for like other optimization flags. And then we'll do this, and we'll say direct call, which is the same thing as Clojure's direct linking. We just call it direct call because in the native world, linking is like a whole other thing. Direct call and direct call. And then when we copy it over here. We'll just say direct call is equal to scratch direct call or false. Because direct call has big implications, even if you have O3 on. Like that's a semantic breaking change. We can bend semantics with O3. We can't break them. You gotta specifically opt into breaking. Okay, so here we should be able to direct call. I guess we ended up changing the header file for CLI, which is why that ended up changing 57 or 57 tasks instead of 9 tasks. We've been doing 99999. So because this is more general for flags, I'm going to rename this to flags as well. Cool. So let's do a B scratch pad run and P ops direct call. It should be true. Nice. Because we ran with O direct call. And if we don't run with O direct call, false. Perfect. Save that, just a name change. Cool. I'll call that good. All right. So today, we watched Andrew Kelly talk about some cool shit and be inspiring, and we implemented some more of this command line parsing stuff. I needed to hook these passes into the command line setup, so now we can easily enable them, disable them. This will end up inside of Jenk's documentation in the Jenk book. But yeah, I'm gonna keep it out of the help documentation for now. This is one of the last things I had to do in order to take all this code and merge it in. The branch that I'm on has all the optimizations for the ray tracer. So looking forward to seeing those show up inside of the continuous benchmarking dashboard that we have, as hopefully some pretty big drops in the Jenk line on those graphs. We shall see. But for now, we'll call it. And I appreciate all of you for hanging out. I'll catch you next week. Next week, we're going to be on to something new. We're not going to be doing any more optimization stuff for a little while. We're going to be jumping into AOT. So look forward to that. All right. Adios. Have a good one.